Let's get started with the silly, entertaining portion of class where you guys tell me a little bit about yourselves. I'm guessing a lot of people hate this kind of stuff, but it's interesting for me. So let's start with cheesy icebreaker question number 1. Who came the furthest to get here, or thinks they did? Okay, I'll start setting parameters. Who flew more than 3 hours to get here? Who flew more than 5 hours to get here? Okay, sir, where did you come from? From Oak Ridge? Ah, so you had connecting flights. But if you had gone straight, it wouldn't have taken quite so long. I need a new metric. Okay, how about who flew 4 hours nonstop to get here? Okay, so where did you come from? Boston? Boston. Did anyone get further than Boston? Anyone further than Boston?
Berkeley, California.
Berkeley is further than Boston? So I would recommend that geography tutorial I think they have in the afternoon. We can check then. Okay, how about who thinks, gosh, that was my only really good icebreaker question. Otherwise, I'm kind of curious what fields you guys work in. So I'll start off, I work in mobile health. I work on a diabetes management app. We've got lots of time series data, hence my interest in it. Who else works on health-related stuff? What do you guys work on? Oh, cool. Do you want to do a deal? Who else works in health? Pharmaceutical company. Do you do anything with time series? Not yet? Maybe, kind of? Cool. Who works in agriculture? What stuff do you do in agriculture?
We help farmers predict and harvest their crops.
Very cool.
No time series.
No time series yet. Who works in advertising, consumer research? What kind of stuff do you do?
Work at Outbrain. We do content recommendations and show up in your ad blocker.
Cool. I'm sure I'm missing a million big things. What am I missing? You guys all have jobs, I'm assuming.
I work in USGS doing earthquake stuff. So there's a ton of time series with
Very cool. Can you say it again?
National Weather Service.
National Weather Service, my goodness. So we've got a bunch of, do you guys, would you say you work in the same thing, or is that just me being like earthquakes, weather?
Operational meteorology.
Okay,
Like 7 to 10-day forecast.
cool. Other? Ocean data. You guys, I mean, at least to a mobile health person, I'm like, you guys all basically do the same thing, right? And Economics. Oh, that's another big one. So what kind of economics?
Currently, it's like global financial flow stuff. But in my previous section, I actually used data from the USGS and worked with agriculture data as well.
Stealing their data, huh?
DNA and RNA synthesis.
Ah, very cool. So time series, sort of?
Lots of times, every time a valve opens, it closes, it gets locked.
Any others? Yes? Astronomy, very cool. You guys are all working outside, not with people. All sounds the same to me. Okay, anyone have a good cheesy icebreaker question? Oh, I didn't want to interrupt. Radar, that's also outside. You all work in the same company, I guess. Who has a good cheesy icebreaker question? Sure. So I am a software engineer at a mobile app called OneDrop. We do diabetes management. I have a bit of an untraditional background, though. In another life, I was a lawyer, and then after that, I went to physics graduate school, and I actually have one quick screenshot of that. So, okay, enough delaying. I guess we actually have to get started with this brutal 8 a.m. tutorial. Okay, so time series analysis with Python. This is an intermediate tutorial. I think it's on the gentler side of intermediate. I've been noticing intermediate has like a really wide range. So if you happen to decide this is sort of overlapping with what you know, I certainly won't be offended if you sort of plow ahead to other parts of the tutorial or go check out another one, totally fine. Just as a warning that for those of you who work with time series, We'll see how much there is for you. Okay, installation instructions. Everyone has seen this already, so let's just get going. Here's kind of the outline of what we're going to do. First, a very brief discussion, why time series, why they matter. I get the feeling a lot of people already know that, probably better than me with the, the earthquake data and the weather data. That stuff is pretty important. We're going to do a quick PANDAS intro to talk about how PANDAS works, just sort of a 10 minutes to PANDAS for those who don't work with it so often. And then we're going to jump more into the meat of things, so dealing with dates in PANDAS, in particular calendar dates. Everyone knows those can be a pain in the butt, so if you do have to work with them, it's really important to be comfortable doing so. Reading and manipulating timestamp data, right? You want to be able to grab data from the USGIS, from the NIH, from the Federal Reserve Bank or wherever you get it, and be able to quickly process it. Common analytical tools, right? How do we sort of explore our time series data? And then we will move into prediction and classification. Couple of caveats, and this is probably an incomplete list. Time series analysis is a particularly tricky and controversial field, in my opinion, so there are no magic recipes. If I mistakenly say something today that makes it sound like something is a cure-all, just make sure you remember at the beginning I said it isn't, so take everything I say with a grain of salt. I think more so than many other kinds of analysis, you really have to be careful about your assumptions and your domain knowledge. I'll give some background as we move ahead, but you also need to really read more before you do real analyses. So I would say you don't want to take anything I show you today and just bring it into work and blindly apply it. This goes back to time series being especially tricky. It's easy to get a model that seems like it's awesome and passes all of your tests. It's got a great p-value, but actually it makes no sense. So again, you cannot sort of automatically or automagically apply anything from time series. I know we say that about everything, but I feel it's especially true here. Tests for goodness of fit, et cetera, are particularly error-prone in time series analysis. So again, just remember that. And I'm going to be probably pretty verbally lazy today, so whenever I don't specify, you should probably assume it's IID normally distributed, all that stuff, centered around 0, et cetera. Okay. So what's special about time series? Well, they're sort of everywhere, right? Where do time series pop up? Most of the most controversial questions of our day arise from time series. Anyone recognize that chart on the top? You've probably seen it every other week for 20 years, if you're that old. It's actually global temperatures, right? Are global temperatures going up, right? And actually, I don't even know if that's a complete graph, but I just saw that a couple of days ago in the New York Times, for example. It just repeats and repeats, and this is the graph everyone's arguing about. Whenever we want to know the future, we're pretty much stuck with time series analysis, right? Whenever we're trying to make policy decisions, make recommendations, figure out whether Armageddon is really on the way, that's all time series. Ditto for thinking about causality in natural experiments, right? So not all medicine is done this way, but certainly there are lots of longitudinal medical studies that mostly just rely on, we're going to sort of see what happened to people and what happened to them after that, because we can't really ethically mess with people's lives, but we try to figure out the causation nonetheless. Okay, so a couple of examples I think are really cool. Speech recognition. That's something people don't always think about as a time series, but really it is, right? The sort of pattern of vibrations that are coming out of my mouth, totally a time series. Physics experiments. This one is from my grad school days. It always used to drive me crazy. We would actually call it some value like force or conductance versus displacement. We would pull on these little nano circuits, and we would see what happened to our electrical conductance and to our force as we pulled. And we always plotted it as force or conductance versus displacement. But what we didn't mention is that we were displacing at a regular velocity. So really what we were looking at was a time series. And I used to have arguments with my advisor about this all the time and what we should actually call the axis. But you see this all the time in physics, and I feel that in physics we don't call it a time series often enough. We're often saying, oh, it's displacement, or oh, it's the changing potential. But most of the time it's a time series. Economics and government policy. So we often see also that different variables are chasing each other. So for example, here, if we look at web search activity for filing for unemployment versus actual unemployment, we see these things are tightly linked, right? So when we're trying to, say, decide how much of our budget we should allocate for unemployment, this is a really good way to sort of predict that, right? And that's another thing people are often trying to do with time series analysis. And then just in the news this week, I spotted these two. So on the left, it's Pokemon Go versus Twitter. Is anybody playing Pokemon Go? I feel like I saw something in the Slack channel about it. Anyway, so the headline was, Pokemon Go is going to overtake Twitter for Android users. And what are they saying that based on when we look at this? Yeah, they're just extrapolating, right? They don't actually know it will happen. But someone probably got paid a lot of money to make that promise to the reporter, who was then able to have this really daring headline, which, I think it's probably true for a little while. Didn't hear you? Unless everyone walks off a bridge. And then on the right is actually an article I just spotted yesterday in the Times, talking about bond rates and saying that our rates are kind of crazy low right now, but not mentioning that they were crazy high, and that wasn't such a good thing either, right, if we look at that giant spike from the 80s. So they're in the news. I would say about half the plots in The Economist also time series, right, usually pretty simple time series, maybe 5 points, making some huge statement, right, like North America is tanking, look at these 5 points in this time series, right? So you have to be careful, and that's especially true for time series, right? You need to know something about your data, so I'm sure everyone has seen this circulating on Facebook, right? The whole 20 amazing correlations, right? So this one is, I think, let's see, it's per capita consumption of margarine versus the divorce rate in Maine. Clearly very tightly coupled, right? There's definitely some causality going on there. So this is, again, why I have those caveats. You don't want to end up in an embarrassing situation like this at work. We all sort of get lazy and make assumptions sometimes, but you just want to keep that in mind. Okay, so switching gears, finally getting to some Python. 10 minutes to PANDAS. Raise your hand if you feel pretty comfortable with PANDAS. Okay, raise your hand if you have never encountered PANDAS. Okay, what about you're sort of moderately comfortable? Okay, cool. So I'm going to take us through the basics. As long as you're comfortable programming in Python generally, I think PANDAS is fairly easy to pick up, and you will have the code, so those who are less comfortable, you'll sort of learn as you go. Okay, so basic intro, most of you know this. PANDAS uses data frames to put data in an easy-to-use format. All the convenience of a SQL-like API, but better. At least that's the way I think of it, right? It's still relational data, but I don't need to write these really long SQL statements. I can just grab things really quickly. It can be fast if you know what you're doing. It can be slow if you don't know what you're doing. I'm not going to be talking about that so much today. It gives you fast read-write to standard storage formats like CSV and databases, so it's also a nice way to port your data however you're storing it and sort of handle that for you. So we're going to look at a quick notebook of examples. So if you are following along, this is notebook 0. 10 minutes to PANDAS. Those who read the docs know I totally stole that title and about half the code in here. So let's go ahead and take a look. Okay, and I link to the docs. I would encourage you to get comfortable with the PANDAS docs. They're very well written, they're very thorough, they give lots of examples. So whenever you're stuck, or even if you just have 10 minutes to learn something new, that can be a great use of your time. Okay, so you can create a data frame in, I think I heard Wes McKinney say 8 different ways. I definitely don't know 8 different ways. I'm sure somebody in this room does. Basically, there's a way however you want to get your data in. So whatever is convenient for you, you can probably do it. Here, I'm going to create a data frame out of a dictionary. So I've got some students, I've got their phone numbers, I've got their age, and I'm also going to use this thing called an index to label my students. And what is that going to give me? This is what it gives me, right? A nice rectangular set of data. I've got my age, I've got my phone information, and I've got these names on the side. Can somebody tell me a little bit about the names on the side? What do those do? Oh my goodness, no. I can't even see it. No, you are totally right. Let's see. How's that? In the back, how does this look? Clover. Still can't read it. Okay. How's that? Clover, you still look like you're squinting. The Clover trio is happy. Okay. Anyone in the back unhappy? Okay. As you can see, I'm not following the Slack anymore, so if you do have questions or stuff like that, just shout it out. Okay, so can somebody tell me a bit about these names and what they're doing? Well, what's it called? What was my named parameter called? The index, right? I'm indexing. It's just the way that I can reference these things quickly, right? Get their data in a way that's quite human readable. So I've got my students, I've got their age, I've got their phone, and I can even just access the index, right? If I want to see what my labels look like, I just look at the index of my data frame. You can also create a data frame with a NumPy array and some column names, right? So here, I'll just make a NumPy array, and I'll do another index, and I will also give some column names. I can do that separately. And again, I get a nice data frame, right? So whenever you need to sort of automatically generate some fast test data, that's generally the way you want to do it. You also have series, which are sort of like a one-dimensional data frame, right? When you really just have one dimension of data, which will often be the case with time series if you're not lucky enough, especially to be an economist with lots and lots and lots of parallel time series. So in that case, you can even just explicitly instantiate it as a series like this, and you can also separately set the index afterwards if you want, and there you go. And you can see it handles NP-nans just fine, so you can have missing data that's not going to cause any problems, right? And as everyone knows, missing data is a reality of life. You can also easily find those nans, right? There's built-in functions to do things like find the nulls. Okay, for those who don't know PANDAS, give me a thumbs up if the pace is okay, thumbs down if it's not so great. Okay, pace seems to be okay. So data frames in series also play nice with plotting, right? You can just plot things. It will, again, handle the missing values, no problem. And similarly with a data frame, you can just plot. And what's really cool here is that I didn't have to do any work. I'll remind you what my data frame looks like. I can do df.head to take a look. This data frame had A, B, C, D for all of these people. What do you notice here? I've got colors, right? It just broke it up for me, right? So people who program in R, for example, this is a bit more of a pain in the butt, or other languages or other ways of plotting in Python, right? But it sort of automatically breaks it up into my columns and colors them nicely. Once you have a data frame, it's also easy to see portions of your data that match what you want, and the same goes for a series, right? So again, let's remember what S looks like. We declared S above, so S is a series. Let's say I only want to see the S's that come later than C, right? I'm like, I don't care about those stupid A's and B's. I can easily do that with a comparison, right? So I have S, and then I stick my logical condition inside these brackets, right? So in this case, I wanted S such that the index of S was bigger than C in the alphabetical sense. What if I want to find those S that aren't null, right? I want to get rid of them. Well, then I can go back to that isNull function we looked at. If S is null is false, right? So if S is not null, that's now going to become my index. I want to retrieve those values, and if I do that, you'll see I conveniently dropped that annoying nan, right? So for functions or analyses that can't handle nans or that it doesn't make sense to pass them in, we're done. Okay, let's go back to our students. Again, to remember what students look like, let's just look at the head of students, although I think that's the whole thing, it's so small. What if I only care about the age? I'm like, I don't care about the phone number right now. I just need to know how old they are. I can easily get that, right? So I can just grab whatever column I want. And I can grab it as an attribute with just my dot, right? Once I already have it in my data frame, I don't need this clunky way of referring to it. Students.age will do just fine. Can select by label. This is a bit trickier. I need to use a .loc. This feels a bit confusing when you start PANDAS. It's not that important, but I did want to point it out, right? So if I just want to get Melanie and get everything for her, I can use something like a .loc. It's called selecting by label. And I can also get just some things about her if that's what I want. And I can select by position with iloc and select different positions. Okay. More exciting about PANDAS, it's easy to summarize your data, right? So sometimes this can be a big pain in the butt. You used to have to write for loops and all that. Now I can just do quick statements, right? Students.age.mean is giving me my mean age. What if I want the max? I can also easily do that. or the min. That's also quite easy and straightforward to do. Questions so far? How's the pace for those who don't know PANDAS? We're okay, cool. You can also add information to an existing data frame. So maybe I want to add the grade. That's probably what I care about for my students. I'm going to quickly do that. And then I want to find out who had, what did I do wrong? Grades, right? Yeah. So PANDAS is forgiving, but not that forgiving. You still have to get your spelling right? So if I'm going to use grade. Who had the biggest grade, right? Who had the max grade? I can, again, use a logical statement, right? So I don't need to iterate through everything explicitly. I just have this nice, easy form of getting what I want. You can easily aggregate information by grouping as well, right? So in addition to taking means, maybe I want the means divided up, right? Maybe I want to divide it up by gender or by age or by phone number, although that doesn't really make sense. So I can group my students by age and see if maybe there's a difference, right? Maybe in this case of the students, the 17-year-olds versus the 18-year-olds are not doing as well. And here I can see, wow, the 17-year-olds are really studying, the 18-year-olds get their freedom and they are gone, right? No more studying. And you can even create categories to aggregate with on the fly, right? So maybe I want to bin those grades. I don't necessarily care if you got an 83 versus an 87. To me, that's just something in the 80s range. So I can also create bins and group in that way. And finally, I can apply functions, right? That's also really straightforward to do. So how many people are familiar with lambda functions? Okay, I'll just go through it quickly. So a lambda function is mostly used when you don't really want to declare a function, right? You want to apply something. You're never going to use it again. It's sort of a one-liner, two-liner throwaway, right? So when you do that, the easiest way to do it is to use a lambda. So you can declare a lambda and actually assign it like I do here. And then you see it works like a function. But the real beauty of lambda is when you're actually going to do something like stick it in an apply statement, right? So let's say I want to increase everyone's age by 1. Maybe everyone had the same birthday. So I'm going to take those students, I'm going to take their age, and I'm going to apply a lambda that just increases their age by 1. So lambdas are especially helpful with PANDAS, with anything where you're sort of going to be applying a function to different chunks of data. There's lots of built-in methods you also want to be aware of. There's actually a really extensive list in the PANDAS docs. There's probably hundreds of them. I'll point out a few that always come in handy, right? Things like getting the mean, getting the count, right? So especially if you want to group by things and count how many per group, you're going to use your count. You can get correlations between your columns, and you can do things like get cumulative max, right? So I strongly urge you, whenever you're sort of thinking of some basic thing you really want, if you're rolling your own or writing your own, you're probably doing something wrong. Okay, so that's PANDAS. Any questions? Cool. Okay. Okay, so now we're going to jump into actually dealing with time. And the way we're going to start is we're going to be thinking about how we can use time to index our PANDAS data frames. So first, let's think about the PANDAS time-related functionality. This is straight from the PANDAS docs. This is what they say it was designed to do. First, generate sequences of fixed frequency dates and time spans. Second, conform or convert time series to a particular frequency, right? So your lab partner did the experiment measuring every 45 minutes, but you actually care about every 90 minutes. That can be a real pain in the butt to do if you don't know how to do it properly. PANDAS makes it super straightforward. And compute relative dates based on various non-standard time increments, right? So especially I think for people who work in economics or anything related to humans where dates matter, holidays matter, PANDAS has made that very simple. There are things like custom business days. You don't need to look up what day MLK was last year. PANDAS knows for you. So that's what we're going to be looking at a little bit now. We're going to move on to the second notebook. So this is notebook 01, dates and times. Let's see. How is that? That's also same magnification. Easy to read? Okay, cool. So we're going to do our standard imports. And we're going to start by generating series of times. So we're going to start with pd.dateRange. Let's take a look at this. Let me clear my output. So I make a range. I call a pd.date range. I start July 15th at 2016 at 10:15. Frequency specified as M. Periods are 10. And let's look at the output and figure out what that did. So what do we see here? How many results do we have? Well, it looks like we have 10. That must be those periods. My start is not July 15th, though. It's actually July 31st. Why would that be? Because I chose months, right? And actually in PANDAS, month goes to end of months. This is the sort of stuff you just sort of learn as you're working with it. It is in the docs. There's also MS, if I want month start, and that will get me to the start of my month. But PANDAS has the feeling that, a month is a month is not your arbitrary July 15th. It does preserve my 10:15, gives me my monthly frequency. What other frequencies do you think they have? Gosh, I can't go fast enough. Okay, so hour, H, did I get it? Yeah, I got 11:15, 12:15. What do you guys think days is? 1? Yeah, I don't know. Let's see what happens with 1. Yeah, nothing good happens. Okay, D, days. I was mentioning that magic about business days. How do you think I get that? B, let's see if B works, business days. Let's see, I have 7, 15, 18, 19, 20, 21, 22, 25. Looks like I did skip something. Awesome. Okay, let's take a look at some of the other options for date range. So if we go and check out the documentation, we see that we have a few ways we can specify what will happen, right? So what did I do? How did I specify things in a way that there was a definite date range? I had a starting date, I had the number of periods I wanted, and I had my frequency, right? So I can tell you, start here, jump this much per jump, and do it n times. That's one way I can do this. What's another way I can do this? Start and end date, is that going to be enough? If I say walk my dog from July 3rd to July 17th, do you know how many times you're walking my dog? So frequency, right? So I need a start, an end, and a frequency, or I need a start, a frequency, and a number of times. So I would like everyone, as a first exercise, to do that latter. So modify this to do a start date and an end date. And you don't need to match this output here, because that would be a little bit annoying to do it in your head, right? The point is that you can do whatever suits what you want to do at the time. So let's do the case of my dog needs walks from July 15th to July 25th, and my dog needs a walk every 8 hours. So first, just for clarity, I'll probably put that my start is there. My start's here. What did I say my end was? July 25th. And I don't even know what time I'm getting home, so I'm just going to say July 25th and not worry about it. Do I need periods anymore? No, I don't need periods, right? I don't want to have to calculate that in my head. And what did I say that frequency was? Every 8 hours. So let's see what that does. Does that look right? Go from 10:15 to 18:15 to 2:15. I mean, it's not a great schedule, but that is what I asked for, right? Okay, so now that I did it that way, how many walks do I have to pay for? How would I figure that out? I count them. Well, what's a fast way to count them? I don't really want to count. Yeah, just get that length, right? So this is even a way, this is something that can even just help you in real life, right? When you're figuring out your vacation or how many of this or that you might have to pay for, right? How many trains am I going to need? How many meals am I going to need? Yes?
Can you go backwards? Can you specify what you meant?
I have not seen that done. Let's take a look. Let's try it out. So, end, frequency, and periods. Yeah. This is what I love about all the time series functionality. You just try things out. It's very intuitive. They have caught most cases you can think of. They are happy to work with you. And I hope you noticed also how I didn't really futz very much about my input string, right? So Anyone want to try this another way?
Can we stack it and minus 8 times?
Minus. This I'm less confident about, but let's, whoa, nope, I was wrong. So you can also count backwards for anyone who wants to do that. Yes?
Can you do something like every 8 hours on business days? Like, you have two specific issues for...
Yes, you can. I'm not going to attempt it on the fly, but there are ways to combine these things. And that is, they have a few complicated examples in the docs. But yeah, you can do things like that. So you can do every hour on a business day, every 3 hours on a business day, 3 p.m. on the third business day of the month. That is all possible with various combinations of these offsets. Okay, what about this other parameter? We haven't looked at all of them. What about TZ, time zone? Anyone deal with time zone data? Yeah, I too am blessed with lots of fun time zone data, right? Tons of fun. Let's go ahead and try out our time zone and see what happens. So they recommend, what did they have in their example? Asia, Hong Kong. Let's see what happens. So what changed now? What do we see? Well, okay, I'll get rid of that red herring. We won't have our negative frequency even though it's not a problem. I've also got my time zone here now, right? Now I've got Asia, Hong Kong. So I can actually relate this, or I can convert it. I can figure out what time that was somewhere else. We're going to do that in a little bit, so I won't belabor the point. And what about this normalized thing? What's up with that? Let's try that out. I don't even what does normalized mean when we're talking about time series, right? I thought normalized was for integrals. Can't assign to function call. Ah, well, that would make sense, wouldn't it? What happened? We've got this, and let's take normalize away. Nothing really happened. What if I do this? What if I make it 1 day? Can't do that syntax. What about now? Well, let me take the time zone away, because that might be making it weird. What do we see now? The time went away. What if I do this? The time still goes away. Why is that? Let's look at that normalized parameter. Normalize start and end dates to midnight before generating the date range. So this is something you might want to use if you really want it to be the same time, maybe even if your data came in at different times, right? You're saying, I don't care that it was 3 p.m., I actually just want it all to be the same time. So that's normalized. We looked at the time zone. Name enclosed we'll get into later, less important. But as you can see, this is like a highly, highly flexible, intuitive tool to handle your dates. Okay, so here we've got our date range. Let's take a look a bit more at this formatting. So I'm going to ask you guys to figure out which of these formats that I've got up here don't work. So go ahead and try all of these out. I don't care what kind of date range you generate, but tell me which one of these doesn't give me what I want. Which one? One of which two? You're cheating, but one of which two? Yeah, you're not. Okay, well, I wasn't hoping you guys would use logical reasoning. I was hoping you would try them all so you can see how amazing it is. But why do you look at those two? Yeah, right? So the thing I wanted to point out here is that PANDAS time series is very pro-North America, so it actually defaults to when things are ambiguous, it interprets them in the American style. So anyone who likes to use European dates, you are not entirely out of luck, but you need to set a flag called the day first flag if you want to use that kind of format. Okay, so I do want to just emphasize, though, like how many different ways you can add dates, right? This is pretty amazing. 2016, July 1, 7/1/2016, July 1, 2016, 2016, 07/01, right? So notice that, for example, if I put it in the ISO date format, even though we're North American centric, it still realizes that's an ISO date format, and that will also work. Any other perverse date formats we should try? Anyone have ideas? I did try Julio, and that didn't work. So it also only seems to work in English. For all we know, that's going to change eventually. But okay, so that is our little intro. Let's talk about the different kinds of data we can have, or data types. So we can have a timestamp. Let's look at this, right? pd.timestamp, that gives me a timestamp. What did I have above now that I think about it, right? When I created that date range, I didn't really think about what was inside there. Let's look at the type of range, the first element in range. Well, that's also a timestamp. So I can sort of create my list of timestamps, which results in a date-time index, or I can create individual timestamps like this. And I can get more detailed, right? So I can say, well, it's actually, July 7th, July 10th, 2016 at 10:15:15. Can I get more detailed? So these timestamps are built on top of a 64-bit data type. Goes down to nanoseconds, actually. So I can add quite a bit more information. You're probably wondering what that format would be. Something like this. So you start seeing it. So what if I wanted to test how far I can go? Well, I'll just keep doing this. Keep adding digits. What do we think is going to happen now? It's not displaying anymore. Oh, well, it just popped out. That's just a matter of convenience, right? So now I'm up to 7 digits in my second. I'm up to 8 digits in my second. I'm up to 9 digits in my second, right? So by default, this is the capability of PANDAS timestamps. You go all the way down to the nanosecond. Does anyone here do work that's relevant for nanoseconds? What do you do?
Time of flight of lasers.
Wow. So what kind of nanoseconds? Tens of nanoseconds? Hundreds of nanoseconds?
1s to 10.
Wow. Okay, so you are going to outgrow this pretty soon, possibly. I think for the rest of us, it's pretty good, but there certainly are fields where nanoseconds matter. I think also in some econ, financy stuff, it also matters, and some other sort of physicsy stuff, it also matters. So it's good to have this capability. What's the downside, though, of nanoseconds? Well, you see, your data is really big. You're taking up a lot of your data storage on detail you might not be needing. Probably for most of us, it's okay, but what I would highlight is by default, that means your timestamp only goes from something like the year 16-something to the year 24-something. And there are ways to deal with that when and if you maybe need to make economic forecasts past the year 2400, but it is sort of an accommodation you'll have to make. I am lucky enough, even if I have to deal with time zones, that I don't need to deal with anything past the year 2016, actually. So that's how much detail you can add. Timestamps also have really useful properties. So let's go ahead and take a look at that list of their components. You can see it's quite lengthy. We've got year, month, day. Those I'm sort of like, yeah, well, I already have that information from the date. Anyone see something here that's useful for work for them? Quarter, right? So maybe anyone who works, what field would you use it for? Well, it's everything for the government, I guess. I can't say we worry about quarters too much in diabetes, but my husband works in business and certainly worries about it, so that much I understand. What we do worry about in diabetes is actually week of the year, because there are those sorts of effects, right? Maybe you have your New Year's resolution and that sort of decays. We also worry a lot about day of the week, so that one's also really handy. And actually, you'll see there's 2 days of the week, right? There's day of week, and then we've actually also got weekdays. Oh, I should blow this up a bit, huh? So these are just like super helpful, and you can even get the weekday name, right? So you don't, I used to have to write this whole like little list, Monday, Tuesday, Wednesday, and index by it. I don't need to do that now, right? I can also just directly get that weekday name. So it's super flexible and easy to use, right? So for example, what's today? It's the 12th? No, the 13th. And what quarter are we in? We are indeed in the 3rd quarter. And let's see if the day of the week, notice the handy autocomplete working beautifully there. Is it the 2nd day of the week? I guess it depends how you define it, but here we see that for PANDAS, Tuesday is the 2nd day of the week. So Monday is the first day of the week, not Sunday. That's another good thing to remember. People can differ. Okay, any questions about any of these? I'll also point out the ones at the bottom. Those can be pretty handy. Is month start, is month end. Those are when you're sort of blindly passing in dates, right? And you really need to identify just the one that was really your quarter end. Maybe that was the really volatile day. Or for us, maybe the month end, right? If people were trying to lose weight or something like that. Okay. I'll also point out it handles AM and PM just fine, right? So I can do 8 PM. It's going to convert it to a more standard time format with the 20. So you can also handle data, maybe user-generated data more often comes in a form like that. Whatever sort of hell your boss can throw at you, PANDAS time series can usually deal with it. How are they lacking, though? Who has data that they don't think can be accommodated so far? Nobody. Yes?
So there are, for example, like historical earthquakes that happened before 1600 that we might have captured.
So if you have to deal with before 1600, there's a whole standard in the docs. I'm not going to go into it, but there are ways to deal with it. You just sacrifice that detail, right? But I don't imagine you care about nanoseconds, maybe not even microseconds.
Particularly not if you're before 1600.
Yeah, so I guess you're lucky if you get the day right, so yes.
We have this discussion with the MJD date, modified Julian date.
Mm-hmm.
So, do you know timestamps in the look?
I don't know specifically modified Julian dates. I do know that it can accommodate, for example, custom holiday schedules. So I don't think that's quite what you're interested in, but yeah. So I don't know about applications to other calendars, but I would think there are, again, easy ways to sort of add offsets. No, so sort of what I'm fishing for is the fact that right now, these are just sort of timestamps. Like I'm putting an exact moment on it, right? But for example, when we think about this tutorial, this wasn't, I mean, it was the brutal 8 a.m. tutorial, don't get me wrong, but it's really the brutally long 8 a.m. to 12 p.m. tutorial, right? And I really want a way to describe that. I don't want to just say I was here at 8 a.m., which is tough. I want to say I stayed all the way till 12 p.m. So I want to start thinking about ways to also represent time in a way that recognizes that it has ranges, right? It's not usually, for most things, something where we just stamped it and we were done. So let's think about time offsets. We have a class called pd.timeDelta that can handle this. It is very flexible, just like we saw with the timestamps. So I might have a time delta like this, 1 day, 1 microsecond, and look at that. It gets it just fine, right? No problem. Let's try 2 months, 1 day and 1 microsecond. Oh, it's not so happy. No, it's not so happy. 2 months. 2 minutes, huh? So you do have to sometimes look at the docs, but it can handle anything you want. You can pluralize 3 days, 1 microsecond. That's going to be just fine. You can add these time deltas to your timestamp. So for example, let's say I started July 1st at 8 a.m. and I want to add 1.5 hours. We see that that actually is no problem. Now I told you it can go all the way down to nanoseconds. So what if I have pd.timeDelta 15 nanoseconds? That's showing up as 0. Is this a bug? Well, let me say, okay, well, what if I go to 15,000 nanoseconds? Does that work? Well, that gets me up there. So the nanoseconds part is working. If I go down to 1.5, well, that's also working. I've got my 1. It's clearly not rounding because that would be a 2. Can anyone think of a way I could sort of try to dig out whether it's in there even if I can't see it? Yeah, I could try adding it, or multiplying is just even faster. So what happens if I multiply this by 100? Oh, well, there it is, right? And what if I multiply it by 1,000, which I had done inside my string? Oh, there it is. So there are these little quirks. I don't want to call them bugs since I'm not a contributor, but there are sometimes things where it is there and you can't see it. You want to really trust it and just use your intuitive checks to confirm it's there. But your nanoseconds are there.
Well, is there a way to expand the resolution of the fractional seconds there? Because it's only showing you down to...
Right. So not that I know of, and I actually asked about this on Stack Overflow, and I was told to put in a bug report. So it's something that's not intended and that they will probably eventually adjust. You can also add these things to your entire range, right? So if you remember that range we had 731, 831, and now we want to say just add one day, right? I think I don't want the month end, I want the month start, and I don't quite remember how to get there. Well, one other way I can get there is to just add a day, right? Add a day to the month end, I get myself to the month start. So let me do that. And I'll point out two things. First, it worked, right? So I added my time delta of 1 day to 7/31/2016, and I got 8/01/2016. There's another more subtle difference. Do you guys spot it? Look for something on this bottom line, the meta information. What do we see? What's different? Yeah, the frequency is different, right? So here the frequency is month. Remember I told you month takes you automatically to the end of the month. And the next one, it has automatically updated itself to month start. So this is really cool. What it means is that all that helpful metadata, as long as you don't do anything too destructive, PANDAS is going to try to preserve that for you, right? So you take your dates that were month-end dates, and you add a day to all of them. It doesn't just say, oh, I don't know, this is just a random collection of dates. It figures out that's still month start, and it updates for you. Now, I don't think this is guaranteed in all cases, but it's something to be aware of and appreciate. Okay, so those are time deltas. The next obvious thing is a time span, right? I want both my start and my end coupled in one thing. I don't want to just be taking my timestamps and hopscotching them to the next spot I want to be. So if you want that, what you really want is something called pd.period. And that is very similar to timestamps. We can mark a period at any sort of granularity we want. So for example, I can do just July 2016, as I'm doing here. Let me do this one step at a time. And then the cool thing is I can have a timestamp and I can actually check if my timestamp falls within that range, right? So that pd.period has both a start time and an end time. So now I quickly have a way to sort of amalgamate the idea of time spans and relate them to timestamps. I can also generate pardon, I lost my spot. Right, so I can also generate a range of periods, right? Just like I made a range of dates, I can also make a range of periods, and that would make sense in the same way, right? Maybe something happens at the exact same time every month, right? Monday at 8 a.m. But maybe really it's all day Monday, right? Maybe all day on Monday every month you have a meeting. Or maybe it's all day every business day, right? That sounds a lot like work to me. So there are other ways you can describe that as well. So you can do a period range hourly. There's also different ways to do period ranges hourly, right? So look at this top range. I started 1/1/12/15. I had an hourly frequency. But just like above, even though I set July 15th, when I did a monthly frequency, I actually end up either at the start of the month or the end of the month. That same logic carries through to periods. So what you notice here is that I've got 12/15, but my periods are actually just starting roundly on the hour. One way I can get around that is I can actually go to a frequency of 60 minutes rather than that 1 hour. And if I do that, I actually get exactly what I want. I get the 12/15. So PANDAS has this instinct/policy that it's going to take you to the round, sensible numbers, which is usually what we want, right? That makes sense as a default behavior. If you need to go around that, you just go down to the next level of granularity.
Is a period still a daytime index?
So a period will give you a period index rather than a date time index.
So if you try to join it with the daytime index, is it going to be a problem?
It depends.
I'm just curious.
Yeah. So what you can do is you can easily convert between them. And also timestamps will match to periods. So in that sense, you can join a date time index to a period. But the other way around won't work, right? Okay. So I already showed you this, but try not to scroll up. I'm going to ask you to go ahead and think, how can you determine whether a timestamp falls within a given period? And give me some sample code. And if you do feel like talking to your neighbor or working with your neighbor, this is a good time to start. Not a tough example, but still nice to get someone else's thoughts. Man, the social corner is quiet. No cheating and scrolling up. Raise your hand if you feel like you're okay on this one. Okay, seems like more time. I will remind you that the PANDAS docs are really good for time series in particular, so if you're not sure what to do, you might want to go read up on PD.period.
So I noticed the help for most of these functions doesn't actually tell you all the different options for the frequency.
Yes.
There's some place where they're all listed out.
Yes, and this is something I continue to struggle with. I'm sure the real Mavericks do not, but this is in fact why I pasted them into my presentation, just to make them easy to find. If someone figures out the logic, and this is in no way to criticize the docs, I just don't quite understand the logic of where they list them, but what you want to do is you see the offset aliases. That's where you want to look, for example, for the frequency strings. So those are actually, for example, not listed with PD.period or with PD.date range, but they're sort of off on their own further down the docs. I think actually if we go, we can look for them together. So here they are, the offset aliases. And there's also, somebody was asking about doing fancy things like, you know, every 3 hours on business day. This is what you'd probably want to look into, is combining aliases. You can do some pretty impressive stuff there. But these offset aliases, for example, are where you are going to find your frequency. But for example, it's under custom business hours, so I'm sure there's a logic to that. I'm just not entirely sure what it is. There are also date offset objects. These are sort of, or anchored objects rather, these are sort of less commonly used. I think these are mostly going to be useful for the econ folks, but you can do things like weekly Thursday, weekly Friday, you know, quarterly frequency, year end in January. You can get pretty crazy. Okay, who feels okay about this now? Who feels more time won't help? Okay, 1 or 2 more minutes on that. 1 more minute. Okay, so let's take a look together. I, again, went with a PD.period of just July 2016, so I've got this. Well, let's take a look, actually. Let's see what that creates, because we didn't talk about that all that much. So you'll notice that if I do this period, where my most detailed information is the month, it will default me to a monthly period. I didn't have to specify that. If I go down and give it a day, it will give me a daily period. If I go and give it an hour, look at that, it gives me an hourly period. So very intuitive, right? What I find the best way to learn is to just sort of think, what if, right? Just like we did together earlier. What if I put in negative hours? What will happen? Almost always it will catch you and save you and do exactly what you wanted, right? And I think that's the intuitive behavior here. If I give you a period and I say, well, it's July 1st, probably I am interested in days. Otherwise, why would I specify? Okay, so I've got my period. These are the two components I care about, the start time and the end time. Let's look at that time. It's a timestamp, right? So even pd.period has timestamps as its property, and it's got an end time. So if I want to figure out whether a time falls within a period, the most straightforward way to do that is, well, first let's pick a time. So let's pick a time not in the period. Let's just say, let's go with one of those earthquakes, July 5th. But I don't want to go too far back. Maybe there was one in 1820, I don't know. So we've got this earthquake, this terrible earthquake. That's how we won the War of 1812, I heard. You don't want to learn your history from me. Did this happen after the period start time? Or before the period start time? Well, let's think. I have a period, it starts at a certain time. Time goes up. So if I want to fall within the period, do I want to be greater than the start time or less than the start time? Greater, right? Because if I'm less than the start time, I definitely don't overlap. I'm not guaranteed to, right? But I have to at least have happened after the period started, or there's no way I'm overlapping. Okay, so p.start time, I want to check if it's less than t. Is that what we agreed on? Well, that's false. So that's sort of a non-starter, right? So, well, that one definitely is not within the time period. Okay, let's try one that is now. So let's just kick this up to 2016. I heard there was another earthquake on July 5th. I wasn't there, but, well, that's still false. Why is that? Can't hear you? July 21st, because my period started on the 21st, right? It didn't start on any old day. So maybe if I make it the 22nd, am I going to make it in? Now I make it in. But this is not good enough, right? This just means it happened after my period of time started. That's not good enough, right? So what's the other side of the coin? I have to start, my event has to happen after the time period started, but what also needs to happen? Before it ends, right? I also can't overshoot the other end. So I've got my p.end time. Do I want to be greater than or less than? So p.end time should be greater than t if I have what I want. So what happened here? I'm getting a false. I wanted a true. What did I do now? Yeah, right. Actually, this is now specified for just an hourly frequency. I have it in my head that I'm doing July, but of course I'm not. So how can I fix this? Get rid of that hour, right? Because that's not actually what I wanted. Maybe I want it, do I want daily? No, that's not, well, let me go back to monthly, right? If I go to monthly, is July 22nd in there? Yes. Is it also in for the end time? Now it is, right? So now I am superset. Questions about that? It's mostly just a matter of remembering what the properties are. There's a little bit of reasoning about how things should relate to each other. The main thing is that time goes up, right? There's the forward march of time. It just gets to be a bigger and bigger number. Think about your Linux Epix timestamps. Even date times work the same way. Okay, let's see. It is 9:06. I think we deserve a break, so let's call it a 5-10 minute break. Max 10 minutes, but if people get back sooner, I'll probably start sooner. I have two very important announcements from the break. The first one is that it actually takes longer to drive from Berkeley to Austin than from Boston to Austin. So I thought, oh no. I thought it was Berkeley to...
The delta by air is smaller than by driving. And it's still, Boston is, I got my geography lesson. Boston is further by 200 miles than Berkeley.
But I feel that in a 1,250-mile journey, 200 is epsilon in many fields. For example, I work in diabetes management. This is really scary if you're diabetic. blood glucose monitors only have to be accurate to plus or minus 20%, which must just be the best we can do. But so knowing that, 200 miles is certainly plus or minus epsilon. So we have yet another person who's like in the range of furthest travel. Okay. Second thing is somebody pointed out to me that there is a much more beautiful and expressive way to check the range, which is what I have just typed now. It's more beautiful both because it's shorter, but also because it shows what we really want to do, right? I think part of why we have to sort of stop and think about it is this is how we're used to seeing a range. And I totally forgot that we can actually put that in the code, right? One of the reasons Python is so great, so beautiful, so expressive, and so simple. So it would be good if you backtrack and put that in your notebook so you can have prettier code. Okay, so we're going to start thinking about how we can index a time series with a date range, right? After all, these date objects, well, they're sort of fun to play with, but I really only care about them if I can relate them to data in a useful way. So how can we index with a date range? Well, I think we actually already did it, but let's think about it a little more carefully. So let's say we have 40 periods. Let's do a pd.series. We're just going to count up. It's going to be a 1, 2, 3 kind of series, and we're going to do a date range with a frequency of 60 minutes, starting at 11:15 on July 1st, and just that number of periods we specified. And let's take a look at that as well. For those of you who are kind of new to PANDAS, remember this dot head just lets you look at the beginning. You can also look at the end with the dot tail. So just good to remember. What are we seeing here? Well, since I expressed this as 60 minutes, you'll see that I kept my 15 offset. If I want to think about what kind of data this is, let's find out what type this index is. It is a date-time index. A date-time index, well, what does a date-time index contain? Let's just look at one of the elements. So let's look at the first element in the index. It contains timestamps. So we have date-time indexes. They hold timestamps, right? So date-time index is when you have that one point in time. Now let's think about why we would use a date-time index, which I just told you about, versus a period index, which is the other kind of index you have available, right? So you have timestamp, date-time index, period index, right? You can index or mark time in either way. Why might it matter? Well, the other thing I haven't mentioned yet, but you're going to see here, is there's some really cool string indexing that makes it very easy to sort of access ranges of dates or a particular date, and you can see that here, right? So we have this TS DT. The DT is for date time, in case that makes it make more sense. So if I want to look at anything that sort of matches to 2016 7/111, I get one thing. I get this thing at 11:15. So somehow it's matching to that. The 11 is hourly. It's going to cover this 11:15. Well, let me think, what if I want to be thinking about these as periods, right? So it's not just that I have a point in time every hour. It's really that I have an hour every hour, and they sort of stack up. Well, I can go back here and I can backtrack. So if I actually want a period and not a timestamp, how would I modify this code? Well, the value of my series is not going to change. My number of periods won't change. What will? Yeah, so I want a period range now instead of a date range. And that just worked, right? Automagic. I just changed one function name and I've got periods instead. How can I confirm that? Well, let's check what our index is. It's a period index. And what's inside that period index is a period, right? So it's actually, when I first started this, I thought, man, there's so many things, but actually you realize, right, it's either a point in time or it's a period of time. Each one has a kind of data type and a kind of index. That's how simple it is. Okay, but right now this is not actually a period range. It's actually a date range. And let's say, I mean, in this case I had 40 rows, no big deal, but what if I actually have 40 million rows? I don't even know if that will fit in memory. It would depend, right? What if I have even 40,000 rows? I don't know if I want to go back and redeclare the whole thing or read it in again. What I'm going to do is I'm going to use these handy functions, toPeriod and 2 timestamps. So I'd like you guys to take a couple of minutes and just experiment with that and pass them back and forth. Okay, so I'm going to interrupt you guys and let's take a look at this together. So I'm going to do TS sub PD for period. I'm going to convert to a period. What happened? Frequently not specified and cannot be inferred from the first element. Well, what kind of frequency did I want anyway? What did I originally have? Sort of hourly. Why do we think it might have been confused? There is a sort of 11:15 thing. Maybe it doesn't like that so much. Let's see, what if we do, let's first check the docs and see what it says. Let's just go to my docs I have in my presentation. I should specify. So let's go back. And I would like to show you guys the docs, but okay. So you're saying do this. D. Okay. Did I really want D though? Can we do better than D? I mean, if I'm like, we have this amazing function, and what it does is it takes every hourly time on July 1st and converts it to the date July 1st. You guys are not going to be that excited. Okay, so what if we do hourly? Okay, so if we do hourly, that's what we get. What if we do what I did above? Did you guys catch what I did above? Remember, I didn't do hourly. I did minutely and just made it 60 minutes because I don't want to be exactly on the hour. I'm just a pervert. What can I say? So I can just specify my frequency, right? And someone was mentioning how these frequency strings are a bit hard to track down and it's not clear what all the options are. I agree with that, but they are pretty consistent, right? So once you do know them or know what you care about, you've got it. And it's always frequency as the key word, and it's always the same strings. Okay, so this kind of looks like exactly what I have, right? So let's compare them. We've got now a period indexed time series versus a time indexed time series. What do you guys see as differences so far? They've both got frequency 60T, D-type N64. What's different? Okay, so there's seconds here and there's no seconds here. Why are there no seconds on period? Right, because it's a period span, right? So it's like every second is part of that period. I don't really need to specify, whereas actually here, as we saw earlier, I could get all the way down into the nanoseconds. Now I can have a nanosecond period if I want, by the way, right? I mean, there's nothing stopping you from going as small as the data type allows. Is that really it though? I mean, is it just a matter of whether I drop these seconds or not? I mean, there's got to be some reason they wrote this function. So let's think a little bit more about this string indexing. And I'll just point out that the complement of 2 period is 2 timestamp. We've already got 1 timestamp, so we won't use that. But it's 2 period, 2 timestamp, right? Date time index, 2 timestamp. Period index, 2 period, right? So these things just keep piling up, but they mostly have the same vocab. Okay, so let's think about indexing, which we were talking about a bit. So when I index the time series, this time-stamped time series, with 2016-7-111, this is what I get. What do you think I'll get when I do it with the period indexed time series? Who thinks same thing? Even antisocial lazy people have to take a stand. Who thinks same thing? Who thinks not the same thing? Everyone is not voting. What? Oh, well, you all were wrong because you didn't vote, right? So, somebody voted. Okay, so those who voted, you actually see that now there's a difference, right? When we have a period, we are actually going to see more things. And the reason for that is that now there's this notion of overlapping rather than just this notion of like, do you match what I want? So this is why you probably care about periods, right? Do periods overlap, right? Maybe they aren't exactly the same, but maybe I actually just care, were these things happening at the same time? For example, if I'm thinking about diabetics, were they eating and exercising at the same time, right? That could be an interesting situation. Or did they eat and take their medication at the same time? There's even some medications, it's actually more of a time period that you take it over rather than an individual moment in time. So when I want to be able to do things like that, this indexing using a period rather than a timestamp is quite useful. Let's see. Let's experiment with this a bit more. So let's see the whole thing. How far do we go? So we go all the way to July 3rd from July 1st. So I can also just grab everything on July 1st. I would like you guys now, go ahead and grab everything for me on July 1st and July 2nd. How can I do that? And by the way, it's cheating if you just do TSPD with this and then do the same thing with July 2nd below. I want a one-liner, not a two-liner. That's cheating. Oh, and also you can't just subtract out July 3rd. That's also cheating.
So is there any place where the documentation for individual classes or whatever is, like, if I want to know what is documentation for timestamp for individual, what are all the options, I can't actually find that. Find the page that describes all daytime functionality, but not individual.
So this is where I hesitate to definitely say no, but the truth is I don't know where it is. That I can tell you. So again, this is actually part of why when I do find something handy in that really long time series thing, I sort of copy it over for my own use, but I am probably totally wrong and it is there. And if anyone finds it, please let me know. So for those who are still working on this, if you want to cheat a little bit or read up a bit more, you probably want to look here in the fancy truncating section of the time series documentation. Okay, so let's start with a simpler question first. Instead of July 1st data, how would I just get July 2nd data? Change the day, right? So I'm going to change this 1 to a 2. Notice I'm working in ISO format. Okay. And same thing for 3. And what if I do 4? Oh, don't have anything with a 4, right? Okay. So I can get July 2nd. So I mean, if I really had to brute force this, I can get July 1st and July 2nd. What would be a more PANDAS-like way of doing this? Define a range. So how would I do that? Okay, so you're saying PD dot. Okay. Okay, and what? So do I want to do a start and an end, or do I want to do a number of periods? Well, it's your solution, so I'm going to put you totally on the spot. Okay, so July 1st. No, we wanted July 2nd, 2016, and equals July 3rd, 2016. What would you do for frequency? Okay, so now I've got a bunch of nans. Yes. So like this. Boom. That was a lot easier. Yes.
You can also do it without the dot block.
Wow, life is getting good. So I can just.
Is it 7-3?
Is it 7-3?
Oh, sorry, I specified 0-0 at the beginning of my time.
0-0. Yeah, so there's two interesting things here, right? So some of you are probably thinking about when you index a list, right? You don't usually include that last index, right? So if I go from 0 to 3, I don't actually get 3. I get 0, 1, and 2. But when you're doing partial string indexing, it's inclusive. So that's really nice because it means that I don't even have to be clever and go to July 3rd at midnight, although that will definitely work. I can just be lazy and say July 2nd. I mean, this is really the lazy man's tool, and I understand we've got a lot of lazy antisocial people here, so there is great joy in the room. Cool. What if I want everything? Well, I'll just go to July 3rd and I'll get everything, right? So it's super, super simple. What are some other things that might work that we do normally with other kind of ranges? We think this will work? I don't know. It doesn't hurt to try. Oh, wow, it did work, right? What about the other way? What if I, for example, what if I want everything on July 2nd or later? How would I do that? July 2nd, and then a colon, and that also works, right? So again, all this intuitive stuff works, right? I wouldn't say put this in production without ever trying or taking a look, but I would say, like, when you're sort of struggling, or if you find yourself sort of generating a range, not that that wasn't a great idea, there's usually a simpler way, right? You don't have to sort of reinvent all the time. What if I do this? Did that work? No. Well, so it's probably correct, but I haven't specified the year, so who knows what the heck year it's using, maybe just 0. In which case this is correct, right? So this is an example of where it can bite you in the butt, right? It will try to save you. It will try to preserve frequency. It does understand all of this partial string indexing, but you have to give it a real date at the end of the day, right? You can't just say July 2nd and think it's your personal assistant and it will say, well, of course you meant 2016 because you're doing the PANDAS tutorial in 2016, right? No. Okay, so let's try 2 more exercises. These are the annoying sort where your teacher asks you to go figure out something that she hasn't even mentioned or taught you how to do. Super fair, super fun. That's why you come to tutorials, right? So go ahead and give these 2 a try. For the first one, I gave you a hint, which is you want to look for the day first flag, and we did talk about this a bit. These are the fancy European style numbers and how to deal with that. And the second one is just a handy good thing to know, right? How to generate a string representation. So hopefully Google will make both of those fairly easy to find. And you could always talk to your neighbor. Okay, so let's take a look at this together. I heard a couple of people found a solution to that first question. How can I create a timestamp with a European-style formatted date string? So how can I do that? Yes. Okay. Okay, so 20/12/2016. Okay, so let me modify the question. I like cheaters, though. It's always good to show some creativity. In particular, I want March 4th, I can't even type, March 4th, 2016, presented in Euro style and converted to a timestamp. So I'm going to reframe the question, refine over time. It's always good. Yes. Can you still do it? Are you sure?
I am absolutely sure.
Okay, what do I do?
So you want to use two date time instead of timestamp?
Okay, so 2 like that. Okay.
And inside you want your 4/3/2016.
4/3/2016.
And then you want day first equals true.
Day first equals true. Bada boom, and there we have it. Questions? So 2 things again to remember. One, that our cheating cheater pointed out, but that I think is really awesome, is that if you don't specify, and if what you put in is impossible with the defaults, PANDAS saves you. That is fantastic. It's also terrible, though. Why is it terrible?
Anything that's possible, it's set to American time by default.
Exactly, right? I mean, you can really get yourself in trouble. You don't even know these things. I mean, who even knows what format? You don't look. You're like, PANDAS takes care of everything. Let me just feed it in. And lo and behold, you have this, what you thought was a time series. It's sort of jumping back and forth in time. Every November, the first few weeks look fine, and then boom, it's all messed up. Was there a question over here?
Oh, no, you can say it's undefined behavior.
Oh, there you go, right? Our favorite words, undefined behavior. So yeah, something we really don't want to happen. So be aware of that. And what was the other thing? And then the other thing is to just reemphasize that PANDAS is very North American centric. I think that's really good for us, not so good for the rest of the world, but tough, right? So I'm kind of a jerk that way. What can I say? Okay. How easy was it to find this to date time? How did you find it? Google, right? We love Google. Python loves Google. It's great. Let's just look at this to date time for a second.
Frustratingly, that's documented, but the timestamp is not. Like all the functions are documented, but not the classes.
So this is where I cannot claim to be an expert because I am sure it's there somewhere, and I also just don't know where it is. But I am going to say it's out there somewhere, even though I can't prove it. It's a matter of faith, if nothing else. But you can find it somewhere, right? And this is a very well-documented library, even if maybe it's not in the form we would normally expect. So just remember that day first if you run into those pesky Euro formats, and also remember this can really nip you in the butt. It's one of those cases where automation might go too far if you're not careful. Okay, what about this second question, getting a string representation in a desired format from a timestamp? Anyone have a solution? Stir from time. Okay, so let's do this one I've already got, like this. And then what will that get me? Yeah, so this is not automatic. It's like, well, why doesn't it know what I want? I mean, isn't it obvious? But anyway, okay, give me a format. Little m, little d. We like that. What happens if I do big M? Minutes. Well, that's definitely not what I want. What happens if I get big D? Well, now I found out, right? So again, you can just experiment. Sometimes experimenting is actually faster than running back to the docs, although it's always good to be familiar with the docs. So for example, if I just wanted to extract 2016, there I go.
This is the same as the Python date time.
Correct. Okay, any questions about this, comments? Let's good to be able to go in both directions. Okay, so I wanted to point out something really cool that, just looking, that Randy pointed out in the chat that I hadn't even thought to test, and then I was just saying to him in Slack, I don't think that's going to work, but actually it does. Some like even cooler indexing. So for those of you who are not familiar with what I'm going to call ternary indexing, but I'm sure there's a real name that I'm forgetting, it's when you use 2 colons. So for example, if I've got a list of numbers from 0 to 20 and I just want the even ones, when I put in 2 colons, right, this first space is my start, this is my stop, and then this is how I want to jump. So if I only want every 2, I can index just numbers by 2. This is not a PANDAS thing, this is just a Python thing. I can also go backwards. So for example, if I want to start at 15, go down to 1 and count backwards, I can do this. So if this is not something you had in your tool bag, it's very useful just in general. But Randy made me discover that actually this works with PANDAS, which is just crazy. So I started myself just overdoing it, right? I thought, well, if I really want to try to get it to work, let me put in a period explicitly with a frequency, right? So here's my start, is that July 2nd, 2016 at 10 o'clock with a frequency of 60T. Let me count up by 3. And you can see it's actually doing that, right? It's counting up every 3 hours. And then I thought, well, Randy actually had a better idea, right? He had that instinct of why make it complicated? Why do p_do.period? Why don't I just put the string in? Because it's actually just going to get converted. And boom, that also worked. I just thought that was amazing. And you can even go backwards, right? So maybe for some particular case, you actually want to list your time series in reverse. You can do that too, right? So that's this, let me start at July 3rd. Your start is sort of where you're like physically starting. So if you're going to go backwards, you actually start later, so you can count backwards. So in that case, when I'm indexing backwards with my -1, I start on July 3rd, I count backwards, and lo and behold, look, I'm starting on July 3rd, and I wind up back at July 2nd. So I almost feel like a saleswoman for this package because it's just so amazing. It's like even the stuff that you think is perverse and like sort of trying to make it fail, it catches you anyway. Okay, questions, comments on that? Okay, we're going to put that notebook to rest. I do think we deserve a break pretty soon, but I would like to really have fun with time zones before we earn our next break. So let's talk a little bit about time zones for those of us who have this daily joy in our lives. And I'm sure someone in this room has it worse than I do, because there's always someone who has it really bad when it comes to time zones. Okay. So first thing, let me make sure I cleared all my output. Okay, I'm just going to start with NumPy and PANDAS. I'm going to make a date range like I had been doing. And that's not producing any output, right? I'm looking at my .tz, it's my time zone attribute on my range. I'm not seeing anything. What if I put an explicit print statement? None, right? There's just no time zone. It's a naive date. It doesn't mean anything. So first thing to learn is PANDAS is not going to try to trap you by defaulting you, say, to UTC. It really just says if it's not there, it's not there. I think that's a blessing, right? We don't want it to try to be clever and maybe look at your operating system and figure out where you were, right? That would probably be a disaster in the long run. So what we need to do is if we want to add a time zone, we have to put it in explicitly. So now let me create a range. I'm going to use the same info, but now I'm just going to put my TZ in when I create it, right? So we're going to be in London. And if we do that and print out our time zone, you'll see we have a time zone info object. It's got Europe and London, and we're set, right? That wasn't too difficult. Uses standard time zone strings. Those of us who work with those are pretty familiar with them. But let's say we're not, or let's say we want to see what our OS supports. There's this handy package, PyTZ. Anyone familiar with this? Kind of familiar? Yep, pretty reliable. Easy to use. So let's just take a look at what they call common time zones and all time zones. Well, if we look at common time zones, there's actually 436 of them, right? So for those of you who thought there were only 24, and that some of those probably don't even include any people, you are totally wrong. And I can tell you, actually, this bites us in the butt sometimes with mobile development. We'll have someone write in, hey, I was using your app in Paris, but you tell me I'm in Malawi. And I always want to be like, guys, that actually is the same time zone, just to be clear, right? But of course, that's not good enough. And that's part of the reason there are so many names, right? Part of it is political divisions and slightly different rules, and part of it is just being closer to the user. First exercise for you guys, just as a, do you remember your Python? What are some time zones that are not considered common? So I've got for you the list of all time zones and common time zones. Let's go ahead and find a few that are not common. This should be easy. Let's call it 1 minute. Okay, so what's the easiest way to spot the difference between two collections? Yeah, sets, right? I mean, Python takes care of this for me already, so why would I do anything different? So I'll make a set out of all time zones. For all I know, it is a set already. I'm just not going to worry about it. This is not an efficiency tutorial, just to be clear. And what am I going to do? Get rid of the others. So what kind of stuff do I have? I mean, partly it's sort of hurtful, right? Like, why is Buenos Aires not considered a common time zone? I don't know. Indianapolis seems pretty big to me, but anyway, that's sort of how you can get some information about time zones. More than that, I'll probably just refer you to Wikipedia and say, you know, battle it out like everyone else has to, because it very much depends on your OS and your data set, and there's multiple sort of conventions about time zones. Let's get back to the beautiful, simple world of PANDAS. Okay, so localizing a timestamp. I already talked a bit about how if you just don't put a timestamp in, it's not there, or a time zone rather. So if we make a time that's naive, like here, that's what we're going to get, right? It's just a time that's naive. It's just this idea of 8:15 in the morning on May 5th. So if I want to, after the fact, add a time zone, I'm going to use TZ localize. Let's say I want to make it TZ US Central, and I'm going to do that. And is that an in-place operation? Well, let's check, right? What happens to T naive? It's still naive, right? So that's one good thing to remember. So if you want to localize after the fact, you have to reassign, right? That's another one of those can bite you in the butt if you're not careful. It is an instance method, so it looks like it might do in place, but it does not. Okay, so that's T naive. What if after you told me the meeting time in US Central, I have to send it to my boss who actually works in Tokyo, and my boss, she's just too lazy to do the conversion. I've got to do the conversion for her. Well, then I'm going to use TZ convert. I'm going to put that same time in Tokyo time, and there we have it, right? So that US Central person will be there at 8:15 a.m., and Tokyo will be there at 10:15 p.m., I guess. Okay, so question for you guys, take a minute. What's the difference between TZ convert and TZ localized? And you can't say their names for those who might cheat the question. It's got to be something more than that. Okay, so what's the difference?
One converts and the other sets.
One converts and the other sets, right? So basically the idea is you can't just use one function, right? Like it will fail in certain cases. So again, you just have to be a little bit careful. It won't catch all your errors. And just to demo that, right, if I do tnaive.convert, I'm going to get an attribute error, right? Because it doesn't have a time zone, so how can I convert it? What if I try to localize something that already has a time, right? So I have t up here that was already localized. What if I try to localize it again? Also is not going to work, right? So it's not really a big deal, but this is one place where, like, if your code has some ambiguity, you'll just have to check for your time zone before setting it. You can't just blindly apply the same function. Okay, ambiguous times, another joy of time zone, right? And particularly of, I don't know, leap year, daylight savings again, you know, all of that stuff. Okay, so you can get some weirdness with time zones based on daylight savings. So I made a range from March 10th, 2016 with 10 periods in Eastern time. What's my period going to be here? What did it turn out to be? Frequency daily. What do you notice? Let's take a look here. Yeah, it went from -5 to -4. It's not an accident that I picked March, right? We've got some daylight savings there. This is just the change relative to UTC, right? We switched over. This is not wrong. This is actually exactly what it should be. It's actually amazing that I don't even have to worry about this. It's just taken care of for me, right? So it's taken care of. That's great, but you could imagine some weird things would happen because it takes care of this for you. You can run into what we would call ambiguous dates. So got some dates here. Is there a time zone attached yet? No, right? I just put in some naive date time indexes. November 6th, 1, midnight, 2, etc. And now I'm going to localize after the fact, and I'm going to put it in US Central. What am I getting here now? Ambiguous time error. Why do you think that is? Again, I didn't pick this date by accident. What happened? We changed time, right? I probably put in a time that, at least the way I labeled it, doesn't even exist, right? You know, like how it's twice a year, you get 2 a.m.s and no 3 a.m., or I'm probably mixing up the order, but we all know what we're talking about, right? The clock goes exactly back. That hour never existed cosmetically, right? Of course it does if you're just sort of counting up the seconds, but cosmetically it didn't. So Python will catch this and tell you, you've got an ambiguous time error. You've got to make some decisions because I don't want to make these decisions for you. So next question for you guys, how do we deal with this? This is pretty easy to Google, so I'm again going to be mean and make you go find the answer. So take a couple minutes and figure out what to do when you run into that ambiguous time error. So in particular, I'm asking, you have these inputs. You want to put them in US Central. What can you do, right? All is not lost, so what can you do here? And I'll give you an extra hint. You should run this in your own browser so you get this error at the bottom, which even sort of tells you what to do about it. Oh, well, that was on purpose. In case anyone looks up. It's shockingly easy to Google, so. Okay, so probably everyone who has typed this into Google has found what I am showing you, which is, this is just how great the docs are. I realize there are some criticisms, but they've got you on this ambiguous time error, and they even tell you what to do. You basically have to add this thing, right? If you want it to try to save you, rather than throw an error, you just put this ambiguous equals infer in. So let's go ahead and do that. So now it didn't throw an error. I have 0, 1, 1, 2, 3. What did I start with? I started with 0, 1, 1, 2, 3. So it's giving me at least labels that seem to be what I want. But how can I check that it's sort of actually achieved what I want? Yeah, I'm going to go ahead and look at UTC, right? We have that one wonderful time zone that behaves the way all time zones actually should behave. So let's go ahead and do that. How will I do that? Yeah, I'm going to convert, right? Not localize, but convert it. So range hourly.tz convert and UTC. What did I do wrong? Cannot convert tz naive, so I forgot that I need to assign this back, right? So range hourly. And then I'm going to convert. And what do I see now? I see 5, 6, 7, 8, 9, which is presumably what I wanted, right? I wrote 2 1 a.m.s, but I actually meant it in the sense of one of those 1 a.m.s is happening an hour later than the other one. How amazing is it that PANDAS knows that, right? They sort of know exactly what my problem was, and they know how to solve it. And for those who don't work with sort of human time or time that doesn't depend on time zones, this seems like incredibly esoteric. And even for people who work with time zones, it is, except that it will crash on the day you're launching your product, which will somehow be on daylight savings time and all that stuff. So it's just amazing that it's taken care of. Anyway, we are going to go ahead and take another break. I put not a poll, well, sort of a makeshift poll in the Slack channel about pacing. I'm going to post it again just so you can sort of weigh in if we're moving too fast, too slow, or just right. So if you have time during the break, please go ahead and vote on that. And let's call it, again, 5-10 minutes, depending on when everyone gets back. Hey. Yeah, so let me show you. I think we will certainly get at least up to the practicum, but that's still not, like, if you're looking for ARIMA or correlation. Yeah, I don't think I'm going to get to it, so.
Okay, thank you very much.
Question. I missed the the last thing we did with the
Okay.
why. I got the error about naive.
Yeah.
And then just missed what we did to fix that. It's a little hard to see the back.
Yeah, so this was, when you do TZ localize, you can only do that on a time series that already has a time zone.
Right.
Versus if you do TZ convert, it doesn't have to. So what I had done, where is it? Right, so here, hold on. Here, I originally had this, and I printed it out, and so in my head I think, right, I have it, but actually I hadn't assigned it back. Yeah.
Okay, it's that simple. Cool.
Yeah. Yep.
Thank you very much.
I also had a question from someone wondering how far along I expect to get. So in case anyone's noticing, I think we'll probably get up to the practicum at this rate, which means unfortunately we won't get to do stuff like forecasting, clustering, spectral analysis. I know, and it's so awesome. But so if anyone needs to head out, that's totally okay. I think the tutorial is fairly self-explanatory, so hopefully still helpful. But I think it does make more sense to sort of continue on with the data handling first. Okay, so we are definitely going too slow because I have no votes for too fast. Has everyone who has an opinion put it in? Okay, cool. So I think we will quicken the pace a bit, and then if it gets too fast, but it probably won't, people can complain. Okay, so let's talk a little bit about reading and working with time-based data. Let's first take a look at different formats that can come in the data. Here's one. I think I pulled this actually from some meteorological government site of some place, so some of you will be much more familiar with this than I am. But you can see sometimes things come in these sort of annoying formats. You might have something that's sort of fixed width, kind of ugly. How are you going to deal with that? Well, PANDAS has a read for everything, right? So in this particular case, it's a fixed width file. If I put in no header, I'm going to get something like this. Not so great, right? But this is clearly time series data. It's crying out for time series, right? I've got 1951, 1952. If I look even a bit further on, I can see it's monthly, right? It goes all the way up to 12, and if I go further than that, I can confirm, right? So this is monthly atmospheric oxygen data. I want a smart way to read this in that is dealing with times, right? So let's go ahead and look at the docs for read FWF, but these parameters will be the same for any of the PANDAS read. The
doc server's been up and down.
It has been. Glad it's not personal. Okay, so are we seeing anything here that looks time related? Names, index call, use calls, mangle, converters. What am I missing? Am I missing something? Oh, there we go, right? We've got parse dates, Boolean or list of ints or names, by default false. If true, we're going to try parsing the index, or we can even give it a list of columns we want it to parse. We've also got this separate parameter to play with, infer datetime format, a Boolean. If true and parse dates is enabled, PANDAS is going to try to infer your format, so you might not even have to put it in. But here's another thing. We can put it in if we want to, right? So there's always going to be a date parser option. This is especially helpful if you have some funky format, right? As you can imagine, it's a lot faster if instead of hiding the ball, you tell PANDAS what your format is, if you know it. So let's go ahead and try these out. So I'm going to do a read FWF. Header none, index column is going to be 0, right? That's where I had my year. But actually I want to parse dates, I want to do 0 and 1, right? I want to include this first column that seems to have the month. Infer datetime format is true. And what is going to happen? Now I lost myself. Okay, we'll do this. If we look at our data, now we've got something really nice, right? It has parsed our dates and it has paired our values, but it could get better, right? Our index is a date time. It doesn't have a frequency. I probably want to do something about that. And I also just want to give my columns and my index a more sensible name. So first things first, let's figure out the empirical range of dates. Go ahead and take a minute and just figure out what's the time span of this data set. So what's a fast way to do this? We can look at some sort of min and max. So if I just look at the min, what am I looking at the min of? It's the index, right? So the min is 1950 January, and the max is June 1st, 2016, right? So there is my range of dates. Also, what's going on with this index? What kind of index do we have? date time index. Is that really what makes sense here? I don't think so, right? I mean, I'm sort of thinking of this more as a monthly average. And actually, the original data set didn't include a date, right? It just included a month. So I probably want to get rid of that. How am I going to do that? So let's try a 2 period. Will that just work? In that case, it just works, right? If you remember, sometimes we have to specify a frequency. PANDAS will tell you, I can't figure out the frequency. In this case, it seems to know exactly what we want. We want to assign this back, so we keep it. And then we've got our data. Can't run that again. Then we got our data in a format that we want, right? A nice monthly format, all the way down. We did the empirical range of dates. We already converted to our complementary representation. Just briefly, I want to point out that we had many options when we read in the data. We took one of them, but I'd like you guys to experiment with timing to see what kind of performance differences, if any, you see with the options, right? And here's your hint. You can either have infer date time format true or false. You can provide a date parser or not provide a date parser. So here's one example with timing. In this case, we do provide a date parser with X and Y. Why X and Y? Because I'm going to give it both a year and a month column, so it's going to get both of those. And I'm going to convert from this string into a date time. And if I run that, file not found, yes. If I run that, what kind of time am I going to see? So I've got something like 13.6 milliseconds per loop. So I'd like you guys to go ahead and try at least one other option so we can get a sense of what, if anything, these options do for our reading in of data. Go back up to all the way to the top. So I have a sample right here with the pd.read FWF. So header is none, index column is 0, parse dates equals 0, 1. These you want to keep the same. And then I'd recommend playing with the date parser and also this infer datetime format. Okay, so here's what I set up. We had the one we were already starting with, right? Using a parser, not using infer datetime format. I also added using infer datetime format equal true, but no parser. And then I tried adding them both. So let's go ahead and see what happens. Where are we? Header. Unexpected indent. I probably have some setting wrong on my notebook. Okay, let's just go back for now. Yeah. Okay, well, when we're not timing it, I'll start adding those breaks. Okay, so let's see what the timing comes out to be. Okay, so using a parser, what did we run into here? Date parse is not defined. My apologies. Okay, so 13.3, 3.9. Using infer datetime, no parser. And 13.2. So what's the clear winner in this case? Using that inference, right? Don't try to outsmart PANDAS. Unless you've really got something kind of strange, you're better off just using their inference. Okay, another cool thing, and this is new in PANDAS 0.18, so if you're not up to date, this might not work for you, but it is really nice, is that if you happen to have a data frame that has things already segmented out and they have the right name, like year, month, day, and hour, so that you've got a data frame that includes columns like this, you can actually just hit it with a date time and it's going to do the conversion for you. You don't even have to put in any formatting or anything, so that's quite nice. Okay. Truncating, just because I want to mention it. Another way to do indexing, right? So we already talked about fancy partial string indexing, but you can also do things like ts.truncate and cut off things before this date and after that date. So if you like something that's a little more expressive and verbal, You can use your truncate function like this. And you can also truncate in ways that don't preserve frequency, right? So that's something to be aware of and embrace when it's helpful for you, but also, be wary of. So for example, if I take rows 1, 6, and 7, I will still have a datetime index, but I will lose my frequency. However, if I give PANDAS the chance to preserve that frequency, it's going to do so, right? So if I go every 2 months from every month, I'm going to keep that frequency. So just some stuff to be aware of when you're reading in data and formatting your data. Okay, so now we get into a bit more analysis rather than just reading our data. We are going to talk in particular about resampling. So raise your hand if you know what resampling is. Okay, raise your hand if you've never heard of it. Okay, so everyone's sort of heard about it. It's this whole problem we all have of you've got something, either it doesn't have any sort of frequency and you want to force it into something that has a frequency, or it just doesn't have the frequency you want, right? Maybe you want to match up 2 time series and one is more frequent than the other. These are cases that PANDAS handles really beautifully and efficiently. So let's take a look at that. So let's go ahead. We've got a time series. It's starting Jan 1st, 2011, 72 hourly periods. If we take a look at this, here's what we've got. I want to convert this to every 45 minutes, and when I convert, I need to think of a way to fill my new rows, right? If I don't, it doesn't really make sense. I have to have some logic. So I'm going to say I'm going to convert to every 45 minutes, and I'm going to use a forward fill. So looking at this, what does this forward fill ffill mean? Yeah, I use the previous month, right? So for example, I went from having data at midnight 1, 2, so now it's midnight 12:45, 1:30, 2:15. 12:45 is not necessarily defined, right? Because these are not time periods, they're time points in time, right? So if I'm thinking about how to fill this in, there's lots of ways to do it. The most common is going to be a forward fill, and I just take the data from the previous cell. Now, why is a forward fill much more common than, say, a backward fill? Which you can also do, by the way.
Pushing something back in time.
Yeah, right? So this is one of these cases where time series is special, right? With other sorts of data, sometimes you can interpolate, and that makes sense. With time series, that's more like looking into the future, usually while you are trying to predict the future, right? So it's not so helpful, and a lot of people who work with time series get caught out with this at one point or another, right? You think your model is amazing, and suddenly you realize you were looking into the future because, oops, there was a backfill, for example. Or interpolation, right, is another form of looking into the future because you can't interpolate unless you know that data ahead of you. Okay, so what did the above code do to the size and content of my data frame? Well, let's think about it. My original data frame was 72, had 72 members. What's this new one going to have? I went to more frequent for the same time period, so what will happen? More data, right? 95 instead of 72 rows. That will depend exactly on how I am resampling. That is it. Okay, go ahead and take a look at the specs for .asFreq on PANDAS and tell me what are your options for filling missing data. Got your methods here. What are they? Backfill and bfill? What's the difference? No difference. It's just a trick, right? Some people like one term versus the other. Similarly, pad versus ffill, no difference. So just something to be aware of. What happens if I use none, by the way? What does that mean? Does that mean like I'm just not going to make a decision and PANDAS will take care of it? What will happen? So let's check that out. So if we do ts as.freq 45 minutes. I did something wrong. I'm going to get NANs, right? Anything that doesn't fall exactly where it used to is just not a number. So that's another way, right? If you don't want to fill anything in, you don't have to, and PANDAS won't force you to. Okay. How do I get to a less frequent rather than a more frequent. Well, I can do the same thing, right? Maybe I have too much data and I want less. This is especially useful, say, if you have an irregular time series, maybe you just don't want some of that, you're just ready to drop it, and you only want the things, say, that came in every 3 hours. So now let's convert the time series to a 3-hourly time series, and if we look at that, we've got 3, 6, 9. Does that make sense versus our time series? Well, it just seems to be matching up what we wanted to match up. So I literally just dropped that data, didn't use it. Is that usually what I want to do? I want to drop the data. Is that good to lose data? No, right? I mean, everybody knows that. So this is where I'm actually going to move to resampling. Resampling is a much more flexible function than .asFreq. AsFreq is really just meant for this up-down conversion really fast and loose. So let's try resampling. So now let's resample every 2 hours. And now what do I want to do? I want to look at the mean, right? So if I do that, I can do ts.resample, 2 hours, take a look at the mean. What's happening now? How is it deciding what number to fill in? For example, at 2, it's got 2.5. At 4, it's got 4.5. How's that happening? Where did this 4.5 come from? From the 4 and 5, right? Because this is really going to give me that time period that goes from 4 to 5. 2 is giving me that time period that's going from 2 to 4. So that's resampling. So what's particularly useful is that we can sample out an irregular time series. So here's an irregular time series for you. You'll see it's really sort of a mess. And I just generated this by choosing random indices and grabbing. Here's my irregular time series. Actually, let me clear my output. Let me just convert this to day, right? And I don't want to do anything fancy, so let me use .asFreq. That gets me nothing. What's the problem here? Yeah, they're not consecutive, right? So all of this will work, but it's not going to work if your data is not ordered. So you can sample, but you're going to need to reorder afterwards. Okay, so that did not work because it wasn't ordered. Let's reorder. We've now got everything in order. And let's now go to a daily frequency. And now what's going on? I've got a bunch of nans now that I went to a daily frequency, even though I had plenty of data. What happened here? Yeah, right. I don't have a method to fill things in. I'm just sort of dropping the data. Really, anything that doesn't land exactly at 4 o'clock, I'm just going to drop. This is, again, where I'm going to do something like a resample, right? So most of the time, you're going to want to be using resampling, not .asFrequency, much more flexible, as we were discussing. So really, I want to resample daily, and maybe I want to count how many per day, right? I'll just do a .count, or maybe I want to take the mean. I'll just do a .mean, or maybe I want the variance. I'll just do a .var. So let's try a couple of things here. I'd like you guys to attempt these. The first two are really just thinking, and the others you will probably want to poke around in the docs for a few minutes. So for AsFrequency or for resample? So
You have to sort of scroll down and find out some.
I think you could apply any of the numerical methods at the end, like .sum, .mean, .max.
yeah, see, actually, I think I'm like learning the logic of the documentation as we discussed. I think one of the things is like the more flexible it is, the less is going to be documented, because it's a bit like aggregation operations in PANDAS, if you're familiar. Like once you've aggregated, you can do a lot of things. And resample is, if you think about it, also just an aggregation, right? You're resampling, you're putting everything there, so you can do your mean, your count, your var. Actually, I think I listed out a few crazy things, like, I don't remember at the moment, but basically try it and it should work. You can also do an apply to just do your own custom function. But feel free to continue griping. I am a griper too, so. Okay, so let's at least talk about the first two. So what if you want to go to a higher frequency, but you don't want to backfill or forward fill?
Interpolation?
You can do an interpolation, but what if I just don't want to do anything? How can I accomplish that? It's like, just don't give me anything. How do I do that? None, right? So I just make the method none. Just to remember you have that option. It's not going to be forced on you. What's our difference between resampling and as frequency? Okay, well, as frequency is pretty limited. Resampling is also going to produce an object that you can do more things on, right? And this goes to your question. Like a resampling is almost like a resampler object, just like an aggregation object. And then it's a matter of what do I want to do with it? Do I want to count it, take the variance, take the mean, take a quantile, etc. Okay, who's making progress on this forward filling only a few days? Okay, let's take another minute on that one and then we will discuss.
So I've got a type error on TS resample.
Okay. What does your TS look like? Is it the same as mine?
Original that he created at the top.
Let's see, so we've got this TS. Maybe we just want to use a data frame. Hold on. That's so strange. Yeah, let's take a look at that during the break. I don't want to tackle it at the moment. Okay. Okay, so let's take a look at this irregular time series and fill NA. So if we look at the documentation for fill NA, we can fill non-values using the specific method. And we've got methods like backfill, pad, forward fill. But what does that mean? I can just fill in nons, right? I don't exactly need a method. So how did you do this? Did you use? Yes. Okay, so walk me through it. So I've got irregular time series, fill NA, and what do I need to put in there? Okay, so let's say I put a limit of 5. No, what else do I need though? Okay, so what method should I use? Let's use forward fill. And I don't seem to have any nans. Why is that? Make this one. Is my irregular time series still irregular? No, because I had resampled, right? So actually, I totally cheated here. Let's go get our irregular time series. Now my indices are, okay. Here's my irregular time series. Okay, we need to regenerate the irregular time series, and then we also need to sort it afterwards, or we're also going to be all messed up. Okay, we've got our time series. Now we want to make our irregular time series by sampling out of our time series. And now we should have a sorted irregular time series, which I believe we do. Okay, so now to get back to the point, which is this fill NA. Fill NA, so we had a limit. Let's go back to that. We need a method and we need a limit, right? So let's make our method that forward fill and make our limit 5. And now we don't see anything. Why is that? What? Okay, where do I need to resample? Okay, so I really need to put my resample here. And how do I want to resample? Hourly, maybe? So now I've resampled, and then I need to fill NA, right? So fill NA is one of these things I'm going to apply to my resampler object. And there's two useful things here. One is I can still select my method, but now I can put some sort of limit on it, right? So maybe I want to forward fill, but that only makes sense sometimes, right? And this is especially useful with an irregular time series, right? Especially if your data sort of comes in chunks, right? So for example, thinking about my app, maybe I have a user who reports in the morning all the time, right? Every 20 minutes, my user is for some reason telling me what medication they took, and then they take a really long break and they don't tell me anything till the evening because they've been busy all day. Well, that's fine, and I probably want to forward fill a bit in the morning, right? When I have fairly frequent, if irregular data, I can sort of bring things forward, but I wouldn't want to say bring forward my 11 a.m. reading all the way to 4 p.m., right? That probably wouldn't be useful. So this gives you a way to sort of say, okay, here's where forward fill makes sense. I can extrapolate a little bit without going crazy and having things that are unphysical. Okay, questions about that? Okay, and then let's just experiment a little bit with our resampler. So if we resample hourly, what have I got? Well, I've got two things. First, I've got my future warning. Resample is now a deferred operation, a bit like an aggregation, right? It's sort of saying, yeah, I've got your stuff, I'm keeping it in groups, but tell me what you want to do with it, right? Because how could I possibly present it this way anyway? And then it's telling me what I've got, which is a resampler. And this is what we were talking about. With that aggregation, there's all sorts of things you can do, right? So basically, any sort of data aggregation you want to do, you can do with these resampling objects. Okay, so that is resampling. Questions about that? This is probably going to be your most useful tool whenever you're working with time series-like objects. Okay, similarly to resampling, the other thing people do all the time when they work with time series is do moving window functions. Who knows what a moving window function is? Right? Okay, it's a very common idea, right? It's sort of like, how are we doing lately? Yes, I know the whole span, but tell me how we're doing lately. And let's take a little bit of a more formal look at this. So if we're thinking about window functions, there's really two kinds of window functions. Most people are more familiar with what I've got on the left, which is the rolling window, right? That's sort of like, let's say you're a small business owner and you want to know how your business is doing. I mean, days might go up and down, but like you might have a good week or a bad week. So when you're thinking how you're doing, you'd probably say, well, how much money did I make over the last 3 days? And every day I sort of care about that. What was the last 3 days? So that's very much like my rolling window on the left. On the other hand, sometimes you think you're actually just getting more data and all the data is equally relevant, or you've decided for whatever reason related to your measurement that all data, more distant in time, less distant in time, is equally relevant. In that case, you're going to use an expanding window, right? In that case, you're always sort of using all of the data you have, but you're sort of looking at how that's changing over time. So for example, on this right side, I have an expanding window, and it looks like I'm taking the mean here. So what you'll see is at first, especially at the very start, it looks just like the rolling window, because for a small time period, they are the same. At the start of my time series, my rolling window and my expanding window are basically the same. But over time, what you see is that this continues to match the lifetime average, which means that, say, if your time series is actually trending downward, your expanding window mean is not going to trend downward nearly as quickly, right? Because it remembers those earlier dates and it weighs them just as heavily as the recent dates. So why use a rolling window function? There's lots of reasons, right? One is you just want to be protected when you're doing your analysis from the vicissitudes of really sort of meaningless, rapid change, right? If you have physical or economic reasons for thinking the change is meaningless. It gives you a way, for example, if you think that sort of shocks are not important or not informative, you can sort of integrate those away, which sometimes makes sense and sometimes doesn't. But what you do need to be aware of is there's something a little funky going on here, right? Which is what? Why is the rolling bit not as good as the actual series? Yeah, so you've got quite a bit of latency, right? And that can be part of the problem. You might say, well, yeah, as a small business owner, you want your last 3 days, but really today is the most important, right? If I made a change today and I've suddenly tanked, I'm going to partly be masking that, or if not masking it, at least delaying that I'm realizing it if I'm looking at the wrong statistic. There's different ways to deal with this. One is you can sort of recenter your data, right? Even just presenting it by recentering it can be helpful, or by weighing differently, right? So I don't need to weigh all days the same. I can say, well, you know, the further away the day gets, the less informative it is, the less I'm going to weigh it in my weighted average. So this is the sort of stuff you want to do with the rolling window function. So let's see how we can accomplish this with PANDAS. Right? So the special thing, and this is really, I feel like, the first time we're seeing time series as time series, right? Because the special thing about time series is that all the points relate to one another, right? When you do time series, you don't start with the assumption that today's value is independent of yesterday's value, right? And if you sort of think about predicting things, right? Like if I say, what do you think? I can't use any example because somebody in the room has domain knowledge, because I was going to say, what's the best predictor of tomorrow's temperature? Probably today's temperature. Now, for all I know, that might not actually be true. Oh, it is. Oh, good. Good to know, right? But so in general, for most time series, what's the best predictor of tomorrow? It's actually today, right? And this is part of the reason we also want to be using our rolling window, right? Is that's sort of the best information we have, even if it's not perfect information. So let's first think about even just relating immediate days next to each other, right? This is called differencing or shifting. Probably a lot of you are familiar with this. It's super easy to do in PANDAS because it is such a common operation. So let's start with a time series, and then let's start with a lagged time series. So I've got my original time series, and to create my second time series, TS lagged, all I did was call this function called shift. And let's see what that did. My lagged is red, my non-lagged is blue. So it did exactly what we were just discussing and what we saw in the PowerPoint, right? It moved it back. In this case, it moved it back 1 period, so that's 1 day. Now this is where we start getting all these synergies from the fact that it's really easy to work with timestamps and that we have all these time-related functions. So let's say I actually want to move things back. I want things to be hourly. And I don't want to just move 1 hour, I want to move 5 hours, right? All I'm going to do is change my frequency and my shift, like this. And check out my axes, right? They're sort of over a period of days. But now actually I've changed it into a matter of hours, right? So I can easily adjust code or accommodate lots of situations. Yes. So here, and let me do this as requested. All right, so we just have our date range. All I had to do was shift my frequency and my number of shifts, and suddenly instead of doing a daily lag, I'm doing a 5-hourly lag. And let's say, actually, this is real data, so I can't just manipulate it. Let's say you're going to say, well, actually, you had hourly data. You can't just go to daily data, but actually I can, right? Because we just talked about resampling. So even to go with real data from daily to hourly wouldn't be that difficult, right? We would just resample up or down, depending what we want to do, and run the exact same code. It would be slightly more complicated. Yes?
I just want to make sure, like, you're calling it lag, but you're using out positive values, but it's actually shifting it forward, right?
Well, is it shifting it forward? Look at the color. So the lagged is in red. Is it forward in time or backward in time? Forward in time.
Right.
Yeah, so you're correct. This is
Make sure I'm looking confusing, maybe.
I think this is my personal weirdness that I think of lagged as forward in time.
Okay.
So maybe make that verbal adjustment for the day, or just look at the colors. Okay, but that gets me to my question. What if I want to shift, and when I say into the future, I really mean into the past? I should do this vocab for normal people and not for myself. How am I going to adjust this? And you already mentioned the thing. What am I going to do? Yeah, I'm just going to do a -5 instead, right? So let's do my -5, and let's just run this all in one cell. And I can easily do that too, right? And actually, I'll change my order of plotting. And I can see that I have shifted that back. So super easy to do shift. There's also something called T-shift. And if you do T-shift, you're actually going to shift your indices rather than your data. It amounts to the same thing. I tend to avoid T-shift because once in a while it can get a little funky. For example, I once had it fail for business days, right? It was somehow including Martin Luther King Day when it shouldn't have. So you can use T-shift, and it's very helpful, for example, for business days, but it's got a couple of kinks that can be unpredictable. Okay, so window functions give you moving aggregate measures of a time series, right? We all know this. And how are we going to do it? Well, let's start with a data frame. And let's just take a look. It's just sort of a random data frame. There shouldn't be any trends or anything like that. And let's just convert. Yep, it's just sort of a random data frame. But let's start doing some stuff with it. Let's do a rolling window, and let's make it a window of 20. And in that case, let's figure out what 20 means physically, right? Because PANDAS is not going to keep track of that for us. So the index has a frequency of daily. So whatever I'm doing right now, it's going to be averaging over 20 days. This is something to keep in mind. Windows is just going to mean row counts, right? So it's up to you to make sure that your time and your row count and your window size make sense for your application. So I'm going to do this really simple df.rolling window equals 20. Let's take a look at my R. Well, that's not impressive. It's just a rolling, right? It's just like that resample. It by itself, like an aggregation object, like a resample, it's not anything until you tell it what to do, right? It's sort of got the data arranged for you. Now it's saying, but what are you actually doing with your rolling, right? What are you rolling exactly? So let's first, for example, do a rolling mean, right? So I'm going to do a 20-day rolling mean. And if I do that, this is what I get, right? I can see my mean plotted out, and I accomplished all of that in what? One line of code to create the data frame, one line to set up the rolling, and then 2 lines to plot it. And of course, all of these can also link up together, right? So I could really just turn this into a one-liner if I wanted to. Okay, so talking about aggregation options and all the things you've got, I'd ask you guys to try out some of these options with rolling. r.ag, r.apply, you can even look at r.kurtosis, r.skew, so go ahead and give those a bit of a whirl. A couple of minutes. Scrolling down, up. It's actually true. More is last too, right? Yeah. Yeah. So if you're not on PANDAS 18, there's a, I was just using it a few weeks ago and I've already forgotten. It might be rolling window. Resample rolling.
Think of it as all, it's like rolling underscore mean, it's all.
I thought there was still a general one though. I think there's something where you can put the method in. Okay, I don't want PANDAS. I know, well, when they set me up, they're like, do you have any cute animal videos? And I actually realized I forgot one, and that would have been good. So you can do a rolling apply. I guess that should probably work even if you're not on 18. So I'm just sort of trying these out along with you. I think this is really cool, like the amount of work you can do with the smallest amount of code. For example, like it's a one-liner, and I can see what the 50th percentile is in my code over time, right? Or if I want to apply more than one function, then I can use, for example, the ag, and I can do something like this. Of course, count doesn't really make sense with a rolling window, but you get the idea. We could do something like var. And we can do all our columns at once, or we can limit it to one column only if there's really only one column of our data frame that interests us. Okay, new to do for you guys. Oh, yes? The color splits just happen automatically. So I had r.quantile 0.5.plot. What's in your, is your df, does that also have all the columns? Okay, cool. Okay, so new to do for you, how would I do a custom function? I want to do a rolling custom function. Take a couple minutes. Okay, let's look at it together in that case. Okay, so what I'm going to do is I'm going to use a dot apply, just like I can use with a data frame column, if you guys remember all the way back to our PANDAS in 10 minutes. So a rolling, in some ways you can think about it like a data frame too, right? It's got columns, it can be aggregated itself, etc. So I can do an apply. In this case, what's my lambda receiving? It's going to receive a NumPy array. It's not actually receiving just one value. So this might be a bit new in terms of writing a lambda that's actually handling something that's not a scalar value. In this case, for example, I did something very silly. I'm going to just divide the first value in the window by the second value. And I certainly need more than that to see some non values. And I'm going to just sort of get really silly numbers. But I should be able to do more interesting things, right? For example, maybe I want to know the difference between the last and the first, right? Basically just replacing the range. How would I do that? So x what? So x.max minus x.min. That's going to get us a range. I kind of want, though, like the first value in the window minus the last value in the window. How would I do that? So x1 minus x minus 1. So what does that give me? Invalid syntax. Extra. Okay, so and I can do it either way, right? If I do x0 minus x minus 1, I'm doing the first minus the last. If I do the opposite, that should just be the negative, right? So if this had some sort of physical meaning for me, I can do one versus the other. So this is the nice thing is, in addition to having all those built-in functions that are probably the ones you want, you can also easily write a lambda. Okay, what if I want to generate a rolling window function of monthly data from daily data? Let's start getting into something that feels like more like work in the real world. So your boss comes to you, he's got daily data, but he actually wants that weird lambda function I just wrote implemented monthly, not daily. Go ahead and give that a try. It might have something to do with resampling. And since your boss didn't give you really specific instructions, this is where you get all that discretion that your boss forgets about. So you make it as easy as you can for you. Also, I know I think I sort of overshot our time for the next break, so I'm hoping to just get through expanding windows, and then we'll also take a break in case people are wondering. Okay, so what do we need to do in this case? There's really just two functions that we've learned that are both relevant in this case. So I need to go from daily to monthly. What is that normally going to be? Resampling, right? I'm especially going to use resampling when I'm going from more frequent to less frequent because I need to decide what to do with all that extra data. And then once I resample, I'm back to a data frame that I just want to do a rolling window on, right? It's just like any other data frame indexed by a time series. So let's take a look at this. Let's say I have my long time series, and I've got this date range starting on July 1st, and I've got a daily frequency. This should be a one-liner, right? I can take that long, I can resample monthly, maybe by taking its mean. I'm then going to take a rolling window maybe of 3 months at a time and take the mean of that and plot and, get some super interesting, almost sort of straight line type thing. But, my boss thought I took all day to do that, and actually it was like, 3 seconds once I'm comfortable with this stuff. Okay, so very briefly, expanding windows. If you remember, we were looking at that graphic in the PowerPoint. An expanding window is like a rolling window where the window just keeps getting bigger as your time series grows. It's like your time series is the window. So how do we do this? We've just got a dot expanding. This will also only work, I believe, on PANDAS 18, so those of you who are on earlier versions may need to find the earlier version of the function, not very different. So if I just do a df.expanding, what I do need to set is min periods, right? How many periods do I want before I'm going to start? I'm just going to make it 1. I'm just going to look at that mean. And again, I can plot it. And what you're seeing here is the typical behavior of most expanding windows, right? They're highly variable at the start when the window is smaller. That's when they're more just going to follow your general distribution of the time series like a rolling window would. But over time, they're going to level off, right? And as you can see, they all sort of level off to around the same mean. Not surprising considering they were all randomly sampled. In fact, I'm kind of surprised they aren't converging a little bit faster. I don't know what's up with that blue curve. So that's an expanding window. When we get back, we're going to sort of mesh all of these together and do a couple of exercises. But let's go ahead and take a 5-10 minute break. It's getting brutal, this 4-hour tutorial, right? So I think a break is in order. Yes. How far? Yes. Also, for those who are not familiar with these snippets, like if you go home and want to see this later, you can just comment that out and load the code also. Okay, so last half hour, final home stretch. Hurrah, you almost made it. Let's go ahead and warm up with a couple more exercises. So go ahead and give these a try. First question, how can you perform an exponentially weighted moving average rather than any of the other options you get from your normal window function? And hint, look for EWMA in your Panda docs. Let's go ahead and just tackle the 1. Okay, has anyone spotted it? Okay, it looks, I'm getting some nods. Yeah, so you can just do an exponentially weighted moving average. I think the only reason it even gets its own function is it is just so common. I have seen it in the social sciences, the physical sciences. I've heard economists use it as well. It just tends to give you kind of like, for things like looking at the mean or the variance, it tends to just be better, right, to not look at things that are not sort of in the center of your window, especially if you're thinking of the center of your window as the relevant point. So it's just a nice natural drop-off. Okay, question 2. When would you use an expanding window versus a rolling window? Can anyone think of something from their work when they would use an expanding window?
So like we have different membership every year, so the expanding window is just to tell you like what the population needs of a particular like variable is every year.
Right, like if you're adding new members or new anything, but where your old ones are still relevant and active, absolutely, you'd want to use an expanding window. Similarly, when I'm thinking about my diabetes app, when we're sort of thinking about like users giving more data, we still care about their old data, right? So we sort of think about them just giving us more and more and more. So that would be like an expanding window with just a count, right? So anything like that where things back in time should just count for a lot. Okay. Number 3, let's try to write a custom function to replace dot quantile for a moving average, right? So, or rather for a rolling window function, not a moving average. So as you saw above, there is actually a dot quantile, but how would you implement that with a custom apply? So let's look at this one together. First, I need a rolling object, right? So I'm going to say r is equal to df.rolling. Again, you need the latest version of PANDAS for this particular way of calling a rolling. Once you have it, you're going to use a custom apply. I hope this quantile function is right. You can tell me if it isn't. When you get your x, you're going to sort it, and then you're going to get the one that corresponds to that position of the quantile. Right, so again, remembering x is just actually giving you a numpy array. So how would you write a quantile for a numpy array? Just stick that in your lambda. Okay, and finally, how would you compute more than one aggregation function on a moving window at the same time? Yeah, you would put it in a list, and what function call will you wrap that list in? .ag, right? So I can have an r df.rolling any window size I want, .ag, and just sort of stick my functions in there. And you can also stick your custom functions in there too. You're not limited to sort of what's in the catalog. Okay, questions about that? Okay, so let's go ahead and take a look at some fresh data we haven't looked at before and see how this all works together. So in this case, I'm going to go ahead and grab some stock data from Yahoo. I'm going to use the pandas.io.data, which does come with a nasty future warning. So if I take a look at it, this is some financial data, so we won't be surprised to see we get an open, we get a high, we get a low, close, volume. I actually don't know what this column means if an economist wants to fill me in.
They adjust it backwards for the dividends that you receive.
Okay.
You take the return and it compensates you for what the dividends
Got it. So that's actually a useful number.
There are a lot of problems with the method. I won't nerd out on it, but basically, yeah, they're trying to smooth it out so that if in the past you were backtesting a strategy, it's comparable apples to apples with other stocks.
I think it's okay for our purposes. Okay, so let's see how much we remember from the last couple of hours. Go ahead, first question. Plot the high and low values of Yahoo's stock, not for the whole time I picked, right? Because I got from 2010 to 2013. I don't know why I'm not doing this more interesting recent period of Yahoo's history, but I am not. Go ahead and plot the high and low values of Yahoo's stock, but only for July and August 2012. If you remember back a couple of notebooks, this should be pretty easy, right? You just want to trust PANDAS, and they'll usually do what you want. Raise your hand if this is too easy. I won't pick on you. Okay, some people admitted. Give me a thumbs up if you're ready. Okay, we'll just take another 20 seconds. Okay, so let's take a look. This is what I did. I'm guessing people mostly did something similar, so I can use that super, super easy and fast substring indexing. Then I can just grab the columns I want, and I can just plot them. And the color even takes care of itself, right? So bada bing, bada boom. So notice I have, okay, I won't say I've done a stock analysis, but I have done something that I could convince someone is a stock analysis with just a couple lines of code, right? A couple lines to grab the data frame, and then literally one line to grab the dates I care about, grab the columns I care about, and create a color-coded graph. Not bad. Okay, new question for you guys. Is the variance of the trading volume for this stock relatively stable over time? And as with all questions coming from your fake boss, you can treat this with as much discretion as you like. Just come to an answer that is meaningful to you. Okay, even for the antisocial folks, I'm going to go ahead and ask you if you've got someone within a reasonable distance of you, just to see if you guys even agree and discuss how you did or would do this. So how many people would say yes, it's relatively stable over time? Oh, so you did it by time. So you're saying there's some period when it is. Okay, so it seems like we already have different versions of the question, right? Depending on, well, can I cut off some time? Can I, choose which times I care about? I'll show you guys one version of what I did, and then I'd be curious to hear what you did. So I just did a rolling window of 50 days, looked at the variance of the volume, and I plotted that. I don't know, that looks pretty bad to me, but you're saying after when? So if you did an expanding, let's take a look at that. So how can I turn this into an expanding? So this has to be expanding, and then I'm going to drop this. So if I do an expanding, it looks pretty good. That'll be one version if I'm going to try to convince everyone the stock is super stable and doesn't have any jumps. What else could I do that might change my answer or give it a different view? Window size. So what's going to happen depending on which way I go? Yeah, right? So if I make my window size enormous, at some point it might even begin to look a bit like the expanding one, right? So like if I say, want this to be 200, yeah, it looks kind of similar now, right? It begins to look more stable. I do also, unlike an expanding window with a rolling window, when I increase my window size, I also lose the first n points, right? Because they're just not, they've all got NAs. What if I go the other way? What's that going to look like? Yeah, super jagged, right? Like, especially if the window is really small, it's basically just like looking at daily data. So how I look at this is going to depend on, my answer is going to depend on how I look at this, right? And this is something you always want to keep in mind with time series. You always, always, always have to be thinking what you're doing and why you're doing it, preferably with some domain knowledge, right? So I don't think it should be someone like me who doesn't even know what days the stock market trades coming in and telling you how to do this, right? You have to have someone who knows what they're talking about. Okay. You actually then anticipated my next question, is the expanding window variance of the trading volume relatively stable over time? And I think we know that it mostly is. So if anyone wants to be that kind of statistician that, does a good job, showing politicians what they want to see, nothing wrong with that, right? Expanding window function can be your friend, right? But only sometimes. So good to keep in mind as far as people thinking about lies and damn statistics or whatever the expression is. Okay. Bit of a trickier question now. On how many days did the stock close higher than it opened? Who's got a number for this? Okay. So what do I do? Walk me through it.
I think the easiest way to do it is to take the length of f and open square parentheses f dot close is greater than f dot open.
Oh, okay, hold on. So the length of f dot close.
F, so we're subsetting F. Exactly.
Mm-hmm.
And then take the length of that. We'll give you the number of days.
That damn capitalization. Okay, so 352. Not so meaningful on its own, though, especially because we're interested in time series. So then my next question, yeah, that was like totally a cheater question for those who know PANDAS. Did the updates become more or less frequent over time? That's what I really want to know, right? Is the stock market doing better? Right, that's how most Americans actually vote for president, whether they realize it or not, right? Are we richer than we used to be? Not that I am not expressing political opinions. Okay, so compared to the simpler PANDAS example just above, what do we need to do now? We're still trying to sort of figure out the same thing, right? What's changing? Nothing? Has something to do with time, right? So what are we doing that's related to time? Yeah, we just want a window, right? We want to make the same calculation, but just on a subset, and we want to keep that calculation moving. So let's see if what I did, and whether it's even correct, right? So we did a rolling window. I said 25, it could be anything. I also created this new column, day gain, which I conveniently forgot to put in. But what would my day gain be? Right, so that would be my close minus my open. And why am I doing that? Why can't I just treat them separately? I mean, I could, right? There's a million different ways to do this, but I liked the idea that then I can just do my apply on one column. I've already got that taken care of because I'm still doing more, right? I'm not just calculating the difference. I'm interested in a statistic on that difference. So I've got my day gain. I'm going to then do an apply with a lambda. Again, remember, this is a NumPy array. It's not a scalar, so that's how you have to treat it. In this case, I did something similar. I looked at the length of those elements of the day gain that are greater than 0 over the total length. So that's sort of giving me a percentage of the days where the gain is greater than 0. And if we plot that, it doesn't look like good news, right? It looks kind of random. But that's what it is, right? So what are things I could do differently here? I could have a different sized window. Not sure it makes much of a difference, right? It seems to go up and down regardless. Gets a little gentler the more I average it out. Anything else I could change? Not so much, right? Like this is not really discretionary, right? Whether I gained or not. What if I do an expanding instead? What do we think that will look like? Smooth out. What did I do? Got to get rid of my window keyword. And that definitely smooths out, right? I'm not sure it shows a positive trend either, right? But at least it evens out. So if we're sort of looking at whether the stock market is a gainer or not, unclear from this. Okay, on to the next one. We've got 8 more minutes, so if we're not dying, I think we can squeeze 1 or 2 more in. compute and plot the mean monthly high value of the stock. So this is, we talked about this, see if you remember, right? Your boss comes in, gives you that daily data, but actually wants the monthly. How are we going to do that? The more of these you do, the more automatic it will get. It will just be a one-liner. You want to get to the point where you don't even think about it. It's that automatic, because there's really just 3 or 4 functions we're talking about. So think about what you know. It's rolling, expanding, as freq, resample, right? So which of these do we want and in what combination? At 12:02. Oh, wait, did you mean just, I thought you meant the earlier solution to the same problem, sorry. Yes, that I can do. I thought you wanted the earlier solution to the current problem. Oh, for this?
Yeah, but she had it still.
What have you used that one?
Just from the near future import.
I think so.
Yeah, or was it cast as yeah, you see the cast
So there's actually, you can find the documentation for that under the aggregation documentation, and there are time groupers. So it would be like pd.timegrouper, and you specify the frequency. So you can do that, and it doesn't even have to be a date time index. It can just be a column, and you can do the same array of, options, every 3 months or whatever you want. We didn't get to that one yet. Okay, so it sounds like we are ready to see the mean monthly high value of the stock. So we're just going to resample monthly, take the mean, get the high, and plot, right? Again, these should just be that easy. Yes?
When we're taking the mean of all our columns?
Well, I selected out high, but otherwise, yeah, it's operating on all of them. So really, if I wanted to be efficient, again, this is not good code. I would actually have selected out my column earlier. Yeah. But otherwise, for example, if I get rid of this, I should see all the means, which, I mean, at this scale, all look the same. If I were to zoom in, they would look different. Okay, let's explore the variance of the differenced volume. So what is differencing? We talked about this a bit. Exactly, right? So we're just sort of looking at the relation from yesterday to today. So difference, and then look at the variance. Okay, so what are we going to use here that we talked about? Yeah, just a shift, right? That's the other thing. So as frequency, resample, window, rolling, expanding, shift, right? Those are all you need, basically. So we can do a shift. I call it lagged. You guys would call it anti-lagged. But we can plot that. And sometimes differencing will help rein a time series in, make it less variable, make it more stationary. I'm not sure I see that in the case of volume. Yes? .diff. So walk me through that one. F.diff. So if we do f.diff, I can do f.volume.diff as well, right? F.volume. Absolutely. Okay, and last one. Does the lag time series correlate with itself, by the way? You guys can call it future lagged. Of course. Prove it. Prove it in the laziest, easiest way you can. Right? At the end of this tutorial, my hope would be that all of the things that used to be headaches are now, super easy one-liners. Go up. So there's a couple of ways to do it. Here's my way. I actually just went back to the correlation function on the data frame. Other ways people want to talk about? Okay, cool. So that's a wrap. It is noon. You guys have made it through. There is actually, as you probably spotted, quite a bit more material, including everything related to forecasting and clustering. I hope the materials will be self-explanatory if you have time. I'm also happy to chat with people during the conference or by email or anything like that, should questions come up. I also welcome feedback on the tutorial if you want to tell me anything after we end or by email. And as you know, there's a more formal feedback process as well. Any questions before we call it a day? Okay, well, thanks for coming for the tutorial, and please do send feedback.